Okay, so good evening, everybody. Welcome back to the session. Hope you're all able to hear me, team. Please do give me a quick confirmation so we'll continue the session. Yes, all of you able to hear me? Yes. Okay, great. Great. So thank you so much, everybody. I think we will get started with a quick recap of what we have done yesterday, and we'll try to jump onto the tools that we are going to discuss in this course today, right? So yesterday, team, we started with understanding of what is DevOps or why do we need DevOps. In fact, before even we understanding the DevOps, we started discussing about the basic definitions such as server or the application, and then what exactly we're trying to achieve with a software engineering model, right? It is an approach towards the development, operation, and the maintenance of a software. That's what we talk about it. So we started understanding various types of applications, out of which we are interested in now with the web applications, especially how do I deliver these applications to the end user. Now, in order to implement the development, operation, and maintenance, we designed a process which is known as your SDLC process, the software development lifecycle. So we had over the decades or over the things, we call it as evolution of IT. We started with waterfall model. We understood about various disadvantages or challenges we had with waterfall model, and various things involved in the waterfall model, such as application architecture, the hosting servers or physical servers, and the data center is what we used to use it. Now we moved on to the next level, understanding the challenges we had it. So which is agile model, we looked at it. And with Agile, we improvised a lot. We had a continuous client interaction, continuous feedbacks. We accommodated dynamic changes with client. So whatever it is needed for the client to look at the product. So we started doing it, and we started with the incremental model, or we also known as iterative model, with which we are able to see the results faster, and then we are able to make the client happy as well. That's what is Agile. Now, as part of it, we also improvised on the application architecture. We moved from monolithic architecture to the NTR architecture, right, which became a lightweight. Now, we also moved from the physical servers to the virtual servers, which made us easy to create servers, and the maintenance has become very much lesser. Now, after that, we also started running our applications on the hosted data center. Not only your own data center, but we also started using hosted data center accordingly. Now, we also understood advantages, but we did discuss about the challenges we had with Agile, how we still are looking for some improvement area, where we think about the regular issue in working fine in development and not working in production. The blame game issues, we had it. Now, along with that, we had limited release windows to release an application, quality of the product being compromised. Along with that, we had some issues with the scalability and the infrastructure readiness issues. So we discussed about all the challenges. We still looking for improvement, right? So that is where we started discussing about DevOps. Now, DevOps is all about, first thing, it is about the culture, or it is about reorg, that it is not a new team to have, but you must reorg your entire teams into a single team to bring the transparency between all the locations. Now, later, we also talk about, it is a collaboration between development teams and operation teams at the culture level, right, and tools level, as well as various things again to achieve the more accelerated deployments into the production. So we did discuss about all these things, right? We understood about the goals of the DevOps, nothing but a speed and a stability of the delivery, or a speed and stability of your application need to be achieved. That is what is the goal, team. So we are looking for a application delivery that is much faster than what we're doing it earlier. So that is what all we're trying to understand. So the end goal is that to deliver an application into the market with a dynamic changes happening in the market, adapt to the dynamic needs of the client, make them available and make it work on regularly, and deliver the application into the market as soon as possible. Now that is the goals that we discussed about it, right? Finally, we understood how do I create instance. We also discussed about in the DevOps model, we started discussing about microservices architecture. How does it help us move the application faster? We also discussed about containers, How does it help us maintain the stability and bringing the consistency across multiple environments, containerizing your application? And apart from that one, we also discussed smelting on the cloud, how cloud can add an advantage to your DevOps model accordingly. So these are all the things, team, that we discussed, and later we also discussed about the AWS to create a EC2 instance and log into the instance. Now that is what you are actually seeing it on my screen as well. Like, we created an EC2 instance yesterday, and then we logged in to the EC2 instance successfully, right? And where we will be working for today. So we will be starting with the basic tools such as version control system, right? So for example, team, I think what all the tools and technologies that we will be covering in our sessions that the next 3 days or today, including 4 days, with the timelines given again. So we will stick to the content and we'll proceed to understand the high level overview of how do I implement a CI/CD pipeline accordingly. So we will be starting discussing, team, various tools. Let me list down the tools that we'll be discussing as part of our course. I think we already have discussed, not sure if I've discussed yesterday, but so let's say that we will start from the version control system, where a developer uses this tool for various activities that he do regularly, nothing but tracking the versions of the source code, where we'll be talking about Git and GitHub, which will helping us to maintain the version control of my source code. Now later we will be talking about a build tool, right, such as Maven, because we'll be experimenting or we'll be looking at a Java based project. So build tools are needed to build the code. So we'll be talking about Maven as a build tool in our sessions again. Now we need a build automation tool as well, right? Build automation tool, where we'll be talking about Jenkins on the high level. So how does Jenkins functions and how does it help us build a CI/CD pipeline again? That is what is something. Now after that, we also going to talk about configuration management, where we'll be talking about Ansible tool, which will help us implement configuration changes across our infrastructure or set up the infrastructure to run your applications. Now we'll be talking about containers. As part of this one, we'll be talking about Docker, right? And we'll be talking about container orchestration, right? I think this is where we're going to discuss about something called as Docker Swarm primarily, right? And then Kubernetes will just have introduction. That's all about it. And apart from that one, we'll be looking at monitoring part. We'll be talking about Nagios, and we're also looking into logging part, where we'll be talking about Splunk as a tool. So these are the tool stack, team, that will be discussing it throughout our scenarios, means maybe starting from today right now till the Friday, right? We will be discussing about these tools. Now within this one team, right? Within this one again, we'll be starting with today, maybe we'll be covering these tools most probably on the high level, how these tools works together, like version control system. Why do I need version control? Or how exactly developer uses it. Since most of you are developers, I believe you would already know about the Git as a version control tracking tool, but we'll be discussing on the top level how it functions, and then later we'll move on to the build tool. Why do we need the build tools, how they can be utilized, and then why or how do I utilize my Jenkins to do this one accordingly. So this is all about it. So I'm trying to cover maximum whatever is possible today, but let's see how does it goes to. So this is just an idea, team. So I'll be starting with now Git or a GitHub as a tool or version control system. We'll try to understand, first of all, what is version control and why do we need version control? What type of version control system tools we have in the market, and then we'll get on to the tool that we're going to discuss accordingly. Just a quick theory for the next 15 minutes, and then after that, we will be getting into the practical mode completely. So with that being said, team, if you have any questions, let me know. We can discuss them quickly, and then we'll try to jump onto the session. So good evening. Should we also log into the EC2 instance, or do we need that? Right now, no need, Pandit. So please follow me, because you cannot do along with me. If you do along with me, then you will confuse yourself. So it's better that you listen to the concepts and understand the concepts. later in the session you may follow the video again, implement whatever I'm doing it, so that will be easy for everybody also. So please do listen to the concept team, and if you have any questions, let me know. We can discuss it afterwards. Okay. So uh, great team. So let's get to the session here. Now we are going to talk about something called as version control system, right? Why do I need a version control system? Or it is also known as something called as source code management tool. Now, before we understand the version control system, let's try to identify or draw a definition for the version. Now, what exactly is a version and why do we need it? Correct? Now, if you think about team, any software that releases into the market, right, that will have an associated number to it. For example, Android 10 or iOS 14 latest or iOS 13. Just this is the one most of the people know about it. So let's say that why I do need a number allocated along with the software name. Now that number we call it as a version number, right? Now why do I need a version again? So it is to identify the changes that you are doing to the application code over the period of time t, which means that if I'm modifying a file every day, now I want to know the differences from the yesterday to today. So how do I track the changes that are happening from yesterday to today? Or do you make a copy of each file and you create new copy? Now we do not do that, right? It will become unnecessarily occupying more storage on your system. So it is not a good practice to make a copy every time you make changes. That is not recommended approach. We just need to have the differences between the versioning of the same file. So it will be easy for me to maintain a single copy, save a lot of storage accordingly. So the version numbers team will help us track the changes that are happening to the files over the period of time. We call it. So version number will simply identify, or version number will simply let us identify the changes to happening to a file in simple words. Now, in order to track these changes, in order to make this versioning, we normally use the version control systems or version control tools, right? That is what is the understanding that you need to have it. So in this case, again, we have a various version control system types, so within which we are using various tools again over the years. Now we started using a centralized version control systems, right? And we also have in the current market, which is nothing but your distributed version control system. Now what exactly this means for us and how does they impact our version changing in your system basically? If you try to understand team, when we are talking about the first type is a centralized version control system. We used to use this, right? We used to use this before the Git basically, or before the current trend. Let's say that this was developed in 2004 and it was used widely till 2014 or 15, right? So people are using this one nowadays also a lot, but this was a type of a version control system which will help us store the versions on a centralized server, right? And then it will let multiple developers connect to it and start making the changes to the code. Developers can concentrate on working on the code. Now the centralized server will automatically create a version for the changes that are happening to a files over the period of time again. So you do not need to worry. The only thing here that you do team is that you will have a centralized server. Now you would create a repository here, right? You would just create a repository, and under the repository you start tracking the changes accordingly. Now whenever a developer wants to make the change, he has to make a copy of that one. So let's say that he will be making a copy of the centralized code. It is the code only that they do it. They will make a copy to the local server like the developer machine or desktop or a laptop where he works on. So he will make a copy and he will start making the changes on his local completely, right? Like every developer works on his desktop or a laptop, whatever it may be. Now, once he done with the changes, let's say that whenever he wants to create a version for tracking the changes he made it, he will normally push, right? Push in the sense he will update the changes to the remote, which is nothing but this one. So consider that the remote would create a version number for it automatically. But whatever the files that are getting changed, every file will be associated version will be available for it. Now here team, So the centralized version control system is helping us collaborate between multiple developers. So multiple developers can work with the same repository and then start tracking the changes for a centralized project accordingly. Great. Now, what is the disadvantage with this kind of a model? Why are we moving to the next type of a version control system, which is a distributed version control system, correct? Now here team, considering the scenario here, what are the problems here? Now consider this one team, what happens if my centralized server goes down? Means that, consider that team, the centralized is like Google Drive. If the Google Drive is down, can you access it? No, right? Something which is on the Google Drive, you will not be able to access it until unless it is brought online again. Now that is the dependency basically, that is a network dependence. The server must be available or developers will be connecting to the centralized server over the internet to create a version history, or over the network, you can say it can be a private network also. So you will be dependent on the network to make the changes or to create a version history for the files that you are modifying it. Now, the first problem is that network dependency. So it will be a slower changes, right? Changes may save it or may not save it because of the network dependency. Sometimes the version history may not be created. In that case, you will have some trouble in tracking the versions properly again. Second thing is that if I don't have a backup of my centralized server, now I would have a possibility that I will lose all my version history if I lose my centralized server again. So there is a possibility that you could lose all the version history that you have maintaining over the period of time. Let's say the last 2 years, and all of a sudden today server crashed and everything got lost in the server. If I don't have a backup for it, now I lost everything for sure. So the version history, the over the period changes you did, everything will be lost accordingly. So there is a problem with this kind of a strategy that people identified. The slowness, you have it, network dependency, you have it, possibility of losing the version systems accordingly. There's a possibilities, right? Now, in order to make the changes, or in order to make it a better work, the work more robust way, right? People started developing a different one, which is called as your distributed version control system, right? In this in this kind of architecture also team, we still have the centralized server, or we also call it as a remote repository, just like your Google Drive again. So you will have a centralized or a remote repository where you will be sharing the code, or where will you be uploading the code so that multiple developers, multiple teams can collaborate and develop towards the same project accordingly. So the centralized server or remote server is still needed for the collaboration. So in a remote repository, you will still have the version histories maintained, that will be there as it is, but the change here is that the developers will maintain a local copy or a local repository as well. That is a major difference that you will see it. So the developers will have a local repository inside which the developer will also maintain the version history. Like you have the version history v1, v2, v3 on the remote, the same version history will be maintained in the local repository also, so that you will have a multiple copies of the same version control or a same version history of your application code, whatever is happening. So in this case, no matter what, how many developers are working, so every developer will hold a copy of the local repository, so where he will be working completely in his local itself, correct? So now that is why you see that the version history has been distributed across multiple servers or multiple systems. Now that is the reason people called it as a distributed version control system, with which, so you will have a less possibility that I lose my version history completely, right? Because if centralized is gone, I can restore from developer one. So developer one is gone and the centralized is gone, I still have a copy from the developer two. So there is a redundancy of your version history maintained. This is very good for maintaining the version history, and just to ensure that everything is good always. Now, apart from that one, because the developer maintaining a local repository, developer need not to depend on the remote repository to create a version history, which means that he will be creating the version history in his local itself. Let's say that he will create whenever he wants to make a version change, So he will be doing in the local repository. Whatever he does, he will be doing to the local only. Now, once he done it, whenever he wants to share it, now that time he will push it, right? Now that is the only time he need to push it to the remote. So whenever he pushes it, it just updates the local version history into the remote version history. So that's all it is going to do at a kernel. So it is a good practice, or it is a very good thing that developer need not to depend on the network. So his productivity will increase automatically to create the versions and save the code changes in a faster way according. So this is the advantages team that you get it. It is much faster when compared to the centralized version control system. Now there is no possibility that you will lose your version history, right? Now, of course, it is increasing the developer productivity as well when compared to the centralized version control system types. Now, if you're talking be examples of these tools team, there are various tools again like SVN, CVS. There are many other centralized version control systems. We had it. SVN stand for Subversion, which is from the Apache. So you may have various things accordingly. But in this world team right now, people do know about, a lot of people know about the GitHub. All right, GitHub is a public remote repository team because people want to share, or people who are working on the open source projects, right? Completely publicly open sourced project. So everything is stored under the GitHub. So multiple people are able to collaborate between, developers across the world are able to collaborate towards a single open source project. Everybody is able to share their knowledge and then do the necessary changes accordingly. So that is the advantage team. That is a remote repository. We have it, GitHub. GitHub is a publicly available remote repository. So everyone who has an internet access can access this repository, or you can also save your code inside that particular repository. In order to make the local versioning, so the developer will use a local software, which is a Git client that he has to install it. Now it will let him create a local repository and then make the version changes in the local repository itself. So there will be a Git client which will help us, or help the developer to track the changes in the local itself accordingly. So this is what understanding that you just need to have it about the distributed version control system, with which we will be able to track every change that you're doing to a software, so that it will be easy for us to roll back in case if I want to go back to the history and you want to roll it back to particular position again. Now, this is just an understanding about what is a version control, what is a version, why do we need a version control system. Over the years, what type of version control systems are we using it? How are they helping developers to track the changes that they are doing to the source code accordingly? Now, this is just on the top level team, the theory wise. So we will be implementing the Git, now GitHub everything. So that is the agenda for the Git that we do it. How do I make a local repository? How to install the Git software? And how do I connect to the GitHub? How do I upload my code into the GitHub? Or how do I get something from the remote to the local again? So these are the things that we will be working on. If you have any questions so far, let me know. We can quickly discuss it before we move on to the session. Before we move on to the practical stuff, we'll be getting this one. Anybody have any questions here, team? Okay, so great. I do not see any questions. Great. So let's move on, team. I think we logged in. So we already logged in, or I already logged into this particular Ubuntu server, which we created yesterday under your AWS, right? So we know how to create and we know how to log in. So I just have my VM that got created here, right, which is in a running state right now. Now let's say that how do I install a software on this particular machine? Is that correct? Now let's go ahead and try to install all the instruction for you team. I have written clearly already under the repository that I shared it yesterday. So hope you have this repository already with you, but I'm sharing it for one more time. Now within this repository team, you have all the instruction already documented. So just follow the repository to do the necessary labs for you. So here it is team, you have a Git thing. So open the Git folder here. Now you will see something called as install and configure a Git. Now when we're seeing this one team, we we are talking about installing a Git client on the developer machine. We are not setting up any remote repository here. We will be using an existing remote repository called GitHub accordingly. So here it is. I'll be running these commands, team. These are the standard Linux commands, and I'm pretty sure that you all have some basic knowledge on the Linux already. So this is called as a package manager. apt-get is a package manager for Ubuntu systems with which you will be able to install a software through the online or internet. That is what I'll be running here. apt-get install software properties common is a package which will help me support softwares basically. Now I'm adding a repository, online repository, from where I can download my GitHub or Git client basically, right? So once you have this one is added to your repository local. Now once it is done, team, you will be able to update, means that I'll just try to check whether the configured repository is reachable or not by hitting an update command basically. You should see that the hit command should work here, otherwise it will throw an error, right? If it is not able to reach out to that the repository which is there, it will throw some error accordingly. But ensure that you should not see any errors while you're running these commands, right? Now here finally we'll install something called as apt-get install git -y. So which is just accepting the licenses and everything. Yes, we are saying for everything here. So once this is successfully installed, which means that we have installed a client on the developer machine, or consider that you are as a DevOps engineer. A DevOps engineer also can install the Git client to work with the Git operations, the very minimal operations that you would do it normally. So in here, team, what I'm talking about is that consider that you are a DevOps engineer. You have your laptop, your personal office laptop, which is given to you, or a desktop that is allocated to you, in which you are installing a Git client. So consider that the system that is given to you is which is having an operating system, and you just installing a Git client on top of it, right? So this is what you just did it, right? So DevOps engineer, you call it, right? So here it is, team. I have just installed my software successfully on my machine, right? Now here, if I want to check the version of this one, git -version. So you will be able to see the latest release of the Git software, which is 2.28, which is a Git client. Okay, I'm specifically saying again, this is a Git client only, with which you will be able to create a local repository and work on the local repository accordingly. Okay. So here, team, in order to work on a source code or any project, normally you will not spill over the files here and there, but you just will configure a folder. Consider that I'm configuring a folder here, which is mkdir make directory, we call it. And let's say that a project is what I'm calling it, or my project or project, whatever you want to create it, you create the folder according to your need. Now I'm saying that my project got created, the folder. Now I'm going inside that folder. Now I want Git to track the changes on this particular folder, right? Git installation is done, which doesn't mean that Git will track everything in your system, team. It is just that you have to initialize a local repository, must create a local Git repository. As I told, the developer or DevOps engineer does not need to depend on a remote repository or a remote system to make the version history in his local. So here, team, consider this is where I'm going to make it, or I'll be initializing a Git repository in my local. So here it is, team. Git init is a command. We run it to initialize a local repository. So it says that initialize the empty Git repository. It creates a .git folder, right? It creates a .git folder within which it is a system folder right now, within which the Git will start tracking your version history and everything accordingly. You will not need to touch that one. Do not touch the .git folder. This is for the Git only. You will be doing the rest of the task accordingly. So we initialized a local repository, right? And within which means that from now onwards, if I make any changes in this particular folder, like create a folder, create a file, delete a file, modify a file, any change that you make it within this particular folder, your project folder, Git will start tracking the changes accordingly. So here, if I type to know the status of my local repository, I'll just do a git status. Now it says that something on branch master, no commits yet or nothing, which means that it is simply telling you that there is nothing available in this local repository as of now to track the changes accordingly. So this is where team try to understand. So how do I start making changes? Create a files, right? What do we do? Now here team, before we do anything, we just want to give the Git repository with your names, but it is also necessary team because when multiple developers are working on the same project, it is necessary that who did what changes, right? Developer one make a different change, developer two make a different change. So we want to understand who or which developer made which change. So we must configure your usernames and email addresses properly so that Git would track the changes on your name accordingly. So that is just an understanding team here. So we just need to configure a username and the email on your system accordingly. That is recommended and that is necessary also. The instructions are here, the config setup, you have it. So git config -- global user a dot name, whatever you want to do it. Change any name team, that's okay. I'm just saying that it is learn DevOps, I call it. Now, along with that, I can also configure my email. Let's say that -- global, right? User dot email. The commands are available on the GitHub team. Please look at them at gmail.com. I'll do it. Now, this is just that I just configured my username and my email address to the repository so that Git will start tracking changes on your name accordingly. So here I say that git config -- global list you do it. So just to list the things accordingly. Now you would see that whatever the details that you configured will be appearing here accordingly. So this is just that configure it. Git will remember your username and the email address. Now that will be populated on your changes or whatever the changes that you make it will be representing your name, whatever the name you configure accordingly. So this is how team we can install the Git in the local server, and we also initialize a local repository using a git init command. Now we also configured a username and email address to the Git local repository so that Git on the local will track the changes that you're making on your name, and then so that whenever you share the same thing with other people also, they can see that the changes done by you are these are the things. So this is the understanding team that you just need to have it. So consider that this is on the top level. You have the idea, right? Now, once you have done this, let's start implementing the changes. Changes are nothing but team, create some files because this repository is empty right now. There is nothing in this repository. So you just have to implement the changes, right? Let me say that I'm going to create a couple of files. Touch, let's say that 1.java, 2.java, let's say that 4.xml. So I'm creating multiple folders or multiple files, whatever you do it, that is what you need to do. So making changes, a change is nothing but creating or deleting or modifying an existing files. You can think about it accordingly. So, right. So here it is. I created certain files here. Consider that you have 3 different files available right now in your repository. Now, what Git would say for this change, right? If I do a git status, now Git is telling you something here. There are untracked files in this repository. Do you want me to track them, right? Git by default not tracking anything again. Git will give you the information again whether should I track it or not, correct? Now this is where team you can see that it is asking that okay, there are some untracked files. Shall I track it? So if you want Git to track these files, we say that we need to stage the files. Nothing but we do a command called as git add, and whatever the changes I made in the current repository, you track all of them. You can say that git add dot. So when I say this one, now those will turn into a Git known things right now. You can say that Git is telling you, okay, now I know this is a new file. which you created. So I'll be tracking this new file from now onwards. Means if you make a change or if you delete the file, Git will have a record of it, right? So that you could revert it if you need it again accordingly. So here it is, team. You have a created or you made some changes. Git said I'm not tracking it. Now you asked Git to track it with a git add command. Now if you want to create a version history, right? This is not a version history yet. Now Git is just knowing the changes you made it, right? Now if you want to make this change as a permanent version number in my log, in my repository, so that I would have to move back to that particular position. Now this is where we say that commit the changes. Git commit, I'll do it, -m. Let's say that a first commit, I'll do it. So if I do a first commit, now this is where you made a version history, create and consider that you created a version 1 for these 3 files accordingly. So all these files are being tracked for version 1. Now if you go on make the changes again, that will be a new version for that particular file from then onwards accordingly. So in order to check the history, a version history in my local repository, I'll do a git log command. Now within which it will show you the long commit ID, where you can see that multiple files have been committed for their version tracking, right? And then it will also show you the author who committed this or who made this commit, who made the change here. Now it is also tells you what time it is committed, which date is committed. All those things will be visible to you. And you also see the commit message, which is also very much important, team. Here consider that if you are working on a feature or you're working on a defect or something like that, now that is where you would also understand the messaging properly, so that people looking at your history will understand, okay, this change or this version number is about to that particular change happening in my source code. So you can understand them accordingly. But this is the process, team. This is a 3-step process basically. All right, we have it. So what is the size of the commit ID? It is the size and the length you're asking about it, or the size? What do you mean by size here? So the length here, it will be some random characters that you can do it. So that will be almost about, right? The length of the things will be always 40 characters. That is what you can see about it. The length is 40 characters. Okay, so means it will, there is no file here, right? It is just a reference. That is it. The files, the actual files will have the reference in the file will be changes. There is no size allocated, just a random number, right? That will be stored on your things. Okay. The file size is about only the files that you are committing with this one. So whatever the size of the file, that will, so for that file sizes, this is the reference number accordingly. Okay. This is not a file, this is just a reference point, just like a static point. That is where it is going to track it accordingly. Right, so with this one thing, we understood it, the 3-step process. Again, I'm repeating it. You make the changes. So at creating a file, new.java, again, I created. You may also modify it. Consider that I'm modifying one file, which is 1.java. So I'm opening a file, I enter some text, right? So whatever you do it accordingly. So here it is. I saved a file. So within this one right now, I made 2 different changes, nothing but added a new file, right? And I also committed I modified an existing file basically. That's all I did it, right? Now you can see that if I say git status again, which will always tell you that, okay, you modified an existing file. You also created again one file, which is I'm not tracking it. Let me know if you want me to track that as well. So in this change again, if you want to do it, git add, I'll do it again. So whenever you want to make git track the changes, you always add it to the git repository. So git would understand what you did it, right? Okay, now it will track the difference between the version 1 and version 2. Like it will mark it for 1.java had a version 1, now for which it will have version 2 right now. It is not as v1 v2, but internally it will make a file reference point to make it a differences accordingly, right? And there is a new file again that it also will get started tracking from now onwards. Now, once you feel that you need a reference point for this one, so again, a version history for this one, again, you would need to commit it. Say git commit -m second commit, whatever you do it, you keep doing like this. So this is the process team within the local Git repository. So this is what you see it. Git log is a command again. So to see the status or see more number of commits, whatever there in your repository. So Git log will show you all the version history that you have it within the local again. If you want it, you can sort it out, maybe different ways, but a Git log will show you the entire version history, entire commits that you did it over the year or over the 2 years of time. If you have thousands of commit also, everything can be retrieved with a single command called as git log, right? If you have the versions, if you have the commit IDs, you will always see that within the git log output automatically. Right, so this is understanding team. Again, just to repeat the same thing again, what I'm talking about. In the Git, it is always about a 3-step process. Try to understand. So within your project folder, or if there is any project folder, you would always make changes. These are nothing but creating or updating or deleting files. You use a standard Linux commands or Windows notepad or whatever the way you edit files. You use the standard editors to make the changes accordingly. Now, once you make the changes, we stage the changes. Nothing but inform Git to track the changes. Nothing but you do a git add dot or a git add file name to add a single file accordingly. Now, once you feel that you added, now if you feel that I need a version for this particular file again, I would do a commit. Commit will create a version history for that file within a local repository only accordingly. Okay. Git commit -m message. This is what is a 3-step process that you would always have to follow. No matter what, whenever you make a change, you must add, you must commit if you need it. Committing can be done, multiple things can be committed at once, but whenever you make some changes again, you must stage it also. That is a mandatory process accordingly. Right, so if I have a cloned a repository, then do I need to run git init command? No, you do not need to run a git init command because it's already a repository that will automatically initialize in the local if you do a clone for it. Right, so how to exit from a git log if I have to large number of commits? You just do a queue, right? If you have a screen full of log commits and you just need to type Q on your keyboard, Pandit, so that will automatically terminate the log itself and you will come back to your terminal again. Go with a Q or Control C is also fine. That should be fine. Okay. So for again, if you want me to create a more commit IDs, again, I would do. So let's say that I'm just going to delete a file right now, which is 4.xml. Let's say that rm4.xml, I'll do it. Simply when I deleted it, git status. Now I just deleted it, one file, and I just want to make git know that I deleted it, right? Git, add a dot and git commit -m. If you want to look at the status again, that will turn into green. If you want to revert that file again, you can do a git restore command to revert the changes. That is what you can do it. But here I'm just going to commit it, right? Commit -m. Okay, say that deleted 4.xml, whatever the file you deleted. I just did this one, right? Now this is how you keep on making the changes. Make the changes, add the changes, and stage the changes. So the recent commit ID, the last commit ID is always known as a head also, right? The recent commit ID. So the recent commit ID will do this one always, right? This is what you see it. So earlier we had a second commit ID as a head, which means that whenever you make a commit, the recent commit ID becomes the head of the repository always. That's all you need to understand. Okay. So here it is. So this is how team you can keep on creating the version history in the local. The developers will be working on regularly about the most changes, whatever the source code, they keep on adding it or deleting it or making changes to the existing things. So whatever they do it, they will be doing this one. As the DevOps engineer, you might write a scripting also For your scripts also, you may want to track the versioning for it. You can also use that purpose accordingly. So, but this is the process stream that you have it in the local, right? Whenever the developer is working on his local, right? So he will be making changes, adding changes and staging changes, and based on the need, he will create a version history accordingly. So this is just an understanding team. How do I look into this one, right? So understand this one, and once this is done right now, consider that you created a version history in the local. Now I would like to collaborate with you, right? That is what all I want to do it. Now, if I want to collaborate or if I want to share this code to another people, now I need to make it available under a remote repository because I cannot share from my local to their local. Or if I want to have a common viewpoint for everybody, I would create a remote repository, right? And then I would upload or I would connect the local repository with the remote repository. Then I would push, right? I would upload it just like uploading the things into a Google Drive, right? And you can share the Google Drive with anybody. They can look at it, they can download it based on the permission you give it again. That will be there. So what is my remote repository? Here is that. In our case, we will be going with the public solution. So setting up a remote repository team is a bigger task, so we are not doing that. So like we set up a local, but setting up remote is also possible. We can set up our own remote repository within my organization. A private solutions can be made, but within our session right now, we're going to use with the public solution, which is a github.com, right? Now for that team, I'll go to this one, which is a github.com, right? So here it is. The github.com is a repository or kind of a remote solution which I have it. So this is a public and open for everybody team which is available over the internet. So you just have to create an account here. So which is completely free. So please feel free to create your GitHub accounts if you have not already done. If you have not already done, so you can just get that once. Now, if you have already an account, just sign in. So I'll be logging into my own account here. So which is Learn DevOps, right? And I'll just log into this one. Now, once you log in team to your account, you will be seeing this kind of a page where you might see empty repositories because mine is having a lot of data here. So you might see many things, but here you will be seeing an empty thing if you have nothing, right? Now, the first and foremost thing here is that you just have to create a repository. Like you initialized a local repository, you must create a remote repository here. Now, this will let me do that. You can go to on the top right corner, right? Top right corner, there is your account settings will be there. Beside to that, there is a plus symbol. Now within this plus symbol theme, if you drop down it, there is an option of new repository. So just click on this new repository. Now here you will just have to enter your project, right? Whatever the name for the repository you wanted. Let's say that I'll just keep it as my project, right? So I just do this one. If it is good, if it is available, then it will give you the name. So under my account called as Learn DevOps, now I created a repository called as my project. Now here I'll making it as public, which means that everybody on the internet can see my code. If I really upload a source code, which is my own development of the project, then you can share it with the people accordingly. So that is what all you do it. Now after this one, let's say that I create a repository that I call it. So just to create repository, it will create the remote repository here simply, correct? Now here team, look at this. This is giving you multiple options, whether you want to connect to the remote repository using HTTPS option or an SSH option, whatever the way you want to connect it, you can connect it. So, but SSH is a little tougher. So let's go with the HTTPS option. That will be easy for me. Now I'll be using the SSH HTTPS option here to connect to the remote repository. And the second thing is that it is telling you create a new repository on the command line, but we have already done it. So I'll be moving on to the next page, which is push an existing repository from the command line. That is what it is asking you to do it, right? So here it is team. You say that a Git Remote Add Origin, and this is your remote repository URL team. Under the github.com, you have a Learn DevOps account. Under that, you have this repository got created. So you are just going to add this particular repository to the local. So we are connecting, or we are linking the local with the remote right now. Consider that if I say git remote -v, right, it will not display me anything. Means it does not have a link, or it does not know where exactly my remote repository is. Now, if I run this particular command, which is git remote add origin, origin is just the alias name here, right? To the entire repository URL, you're just creating an alias, right? Now here team, I'll just run this command. Now, once I run this command, if I go on, look at my git remote -v, now you will see the URL listing. Means that for pushing, means whenever I push something from the local to the remote, it will be pushing to that URL. Means that will be connecting to that repository and uploading all my source code from the local, as well as the version history from the local, updated to the remote repository accordingly. Now for fetching, means that if there are any changes that are available in the remote and I want to get them, then I do something called as fetching. That will also be done with the same URL again accordingly. So once I do with this one team, all I'll do is that I'll simply do git push -u, we call it, right? You know, this is what I can do it. -u origin upstream team. -u means that upstream, we call it. Upstream is nothing but the remote repository always. A remote repository, we also call it as an upstream project. This is your local project or local repository, and there is a remote repository or a remote project. The remote project is also known as your upstream project in the terminology wise. So upstream origin, origin is just an alias name. If I refer to origin, we are referring to this particular URL. To make our command simpler, we did it. And we also create something called as master. Master is kind of a branch, we call it. So branching is a concept in Git which will help us to make our releases smoother. But keep that branching concept society, but this is what it is. Now, whenever you do this one, it will ask you the credentials, the same thing that you entered on the GitHub. Let's say that the account name and the password. So this is what all you just need to do. So this will upload, right, whatever is in your local, including the source code, which means that the files that you have it here, and whatever the commit history that you have it, right? So whatever you have, the commit history, version tracking system, plus the source code, everything will be uploaded here, right? If I just give this one a refresh this, now you will be able to see whatever I had in my local, everything is available here, including the commit history. Now this is why we call this as a distributed version control system. You can see that whatever the commits I made it, first commit, second commit, and deleted the 4.xml. Now which is committed by the learn DevOps, whatever the username that you configured on the local, right, that is there. So including the commit ID, if you want to really look at it, you can see that this is happening here, right? Whatever you have done, so everything is clearly mentioned, including all the long commit ID and everything, right? So this is how team you can understand about how do I connect my local with the remote, and how do I upload my changes to the remote server accordingly. So this is how team the developers are working. You may think about it, right? So this is what all about it. Now consider that, right? So there is a new developer joined your team. Consider that you have a lot of project work going on. You need other helping hands for you, more hands to develop your project. So you started hiring a new developer, right? So you have done with the local operations. Now you're able to upload it to the remote from your server. Now you are the developer one who are working on your project so far. So you got more work. So you hired a new developer here. Now this guy, what he has to do it, right? The new developer, he can just simply make a copy of the remote. So consider that you have my project here with all the changes which you have done so far. Everything is there. Now this had a local my project, right? Now the new developer team, he does not need to do it. He will just install the Git client. definitely on his system that is required. So he will have to get the project from the remote to the local. So he does not need to initialize a local repository at all. He can just clone the repository or get the remote repository into the local. So we have a way to get the remote repository to the local, right? So how do I do that? The operation is called as your Git clone, right? A Git clone is an operation basically which will help to get a project from the remote into the local, right? And this is the first time task only, the first time use only, right? This is what the one time use only. The first time when you want to get a project from the remote to the local, you will be doing this operation accordingly. For example, right, everybody, I mean, I'm not sure if you have your servers ready or not, but let's say that whatever the URL that I have it team, you can simply start doing a clone. You can take the URL from the browser directly here on the browser window, right? Or you can do a code here, click on the code option, then you will see a URL here, which is this one. So here it is. Now here team, you can see that. So HTTPS, I'll do this one. I'll just copy this, right, URL. Now I can come to my local server. Consider that this is not available in my system team. Or let's say that I'll remove this one, rm-r my project, right? Now I just cleared my project, which means that consider this is a fresh machine right now, which has just a Git client installed. There is nothing available for me. Consider that I'm a developer too here, right? Now if I'll use this one, I'll see something. Git clone is a command, and I just give the URL of my remote project. Now this will simply create a folder called as my project. It will simply clone everything into my system account. So this is what I'll do it. Now if I do this one right now, you will see that my project got cloned, or the entire project got copied into my system, right? Let's see that I'll go to my project right now. Now within this one team, the Git would already initialize it automatically. You would not initialize it again, because whenever you clone a project, since you're already getting a project, Git will automatically initialize it. It will automatically create this local repository for you. Okay. Now once you have this one, you can see the same commit history, the same source code, everything will be coming onto your local. The same thing that you had in the remote, now you are getting into the local as well. So this is how team you would work with the repositories that you have it. For example, working on the local, pushing it to the remote. From the remote you can get to the local with a git clone operation. You do everything, right? Now once after this one is starting, when multiple people are working, there is one other operation that we regularly use it, or it is a recommended operation before you start the work every day, right? That is nothing but assume that you are a developer too now. You took the repository, but meanwhile you're working on this repository in your local. Consider that a developer one made some other change. For example, team, I do not have another machine, so I'm making changes here directly. So here I'm creating a new file. Let's say that consider that this is my dev1 change, right? He added some file and he committed to the repository, which means that he just updated the remote repository. Now that team, you just see that there is only one difference between the local and the remote repository here. So should I clone it again, or should I do something else here, right? Because I want to get the changes only, but I do not want the entire copy again, right? If I make a copy again, that will make me a duplicate copy on my system. So I do not want to do that. I just want to clone, right? Whatever the commit that you have it, the dev1 change.txt file, along with the new commit ID that is coming up, we just want to get that change to the local. So what operation should I use it to get that change to the local is that you do a simply called as Git Pull. So Git Pull will compare the local repository and the remote repository. If there are any changes that are available in the remote that are not present in the local, it will simply get them and add it to the local repository automatically. It will not override the changes. Do not think about overwriting changes if there are something in my local Will it override the things? No, it will not override any point of time. So Git will never overwrite it. If it is overwriting, then all the purpose of version control system will be gone off. It will just add the changes. It will give you some warnings, forget about it. But here it is adding the change, right? Now, if I look at this one, ls-l, you would see that dev1.change.txt got up here, along with the log history also will come up. You can see that the new commit ID, which is done here, the create dev1.change.txt something, whatever I have done it on the remote, it has come to the local accordingly. So this is how team you would need to understand how developers regularly work on a GitHub repository, right, or a centralized version control system to make the versioning happening, right? They will be working on it completely however they do it, but at the end of the day, the only thing is that right, you must understand the developer is responsible for tracking all the changes for the source code. Now he has to update to the remote. From the remote, we can take simply a copy and then start working on it accordingly for further delivery process accordingly. So that's all you need to understand about it. So can I save our username and a password for GitHub repository in Ubuntu to get rid from the entering again and again at the time of pull push? Okay, so yes, you can do that. There is something called as credential manager. Git would save in the local, it would save your credentials of GitHub. Definitely that is possible, Himanshu. You can do it. Again, you must be very careful when you're storing your username and password on your local. That must be in an encrypted format. If somebody steals your username and password, you would be in trouble. So you must be very careful storing something in a plain text format. So there is something, a separate tools that you need to use it to store it, and Git can read the username and password from that. For example, there is something called as credential managers for Git. You would have to run through that and you have to store your things accordingly. That can be done. So in remote, if any change is done, we need to commit first and then pull. That's correct, Atul. So whenever you make a change in the remote or a local, you must commit it, right? Whatever the change I do it here, maybe I'll open this file, I'll add it, right? Means I'm modifying this file here, I'm adding some text in my file. Once you make the changes, you must commit. You must give the commit message like you do a git commit -m. You can drop a message here or you leave it a default one here. If you want any additional description, you can give it that also. And you have to commit the changes. Once you commit the changes, then only you will be able to pull. Means whatever it is, you have to pull the change now, a new.java, which is got modified, right, which is got modified. If you look at the content of new.java in the local, there is nothing. So there is nothing in the file, so it is not displaying anything to me. But considering that, if I think that there is something modified in the remote, I want to get that to the local, I'll do a git pull, right? It is already committed in the repository remote, and you're asking to get that change to the local. I just do this one, so it will just get that particular change, new.java. That's what it says to you. If I do this, now you don't see, but if you do a cat new.java, you will see the content of the file that you modified there accordingly. So that's how you need to understand about how to get the changes from the remote to the local always, right? Now it will also get your log history, git log. You can see the latest commit ID again, that is update new.java is being updated in the local repository also. So at any point of given time, the version history is maintained in the local repository, as well as in the remote repository, as well as in the colleagues systems also, like multiple people or multiple developers who are working towards the same project will always hold a copy of version history. Thus, there is a possibility that you cannot lose your version history at all. So, right, that is what I can say to you. Right, this is all about the Git team. How does it work? So what is the relation of etc resolve.conf to Git? I was facing this issue about error temporary failure in name resolution while cloning. What is that error again? So temporary failure in name resolution while cloning. Is that the only error that you get it, Vinay, or something else it shows to you? It says that it is not able to resolve to the website. That is what it is. The name servers, because you are cloning, right? Means what is that? What is the URL that is cloning it? What is the URL that you're cloning? Can you give me the URL? Git clone operation right? Is it a github.com or something else? Usually the resolve.conf responsible for reaching out the different domains, right? So how you're able to do that is something, the name servers that will be there. So this is your private repository, you mean to say, which is on the GitHub or within your organization. Okay, it's in private network, then that means that your server is not able to reach to that particular repository. Okay, it's Mercurial, that's fine. So that is also this way. It is not able to resolve, means it is not able to ping. Did you try pinging the servers maybe? Try doing like this, right? Ping github.com, something like this. Maybe you have your own private URL. So it should respond. So if it is not able to respond also, your server is not in the same domain as your repository is in. So there is a network connections tied to this one. So that is what the issue. That's what I'm telling you. Your servers or GitHub is not reachable, means that the Mercurial server is not reachable from your server. So how does your server looks for the remote host is that using the resolve.conf entry, using the name servers. There is something called as DNS servers, right? So how does your server able to reach out to a particular URL is that using the resolve.conf entry always. Okay, means from where all you can enable the connections to the server, like allowing the server to connect to various domains or various repositories using the resolve.conf entry. We do it always. Okay, so it says unknown host, which means that your server is not the GitHub, the remote repository in the Mercurial is not reachable from your server. That's what is the reason you get that error. Okay, so great. Now, I mean, this is just on the top level thing what we wanted to understand about Git. So, I mean, this is just a top level view, as I said again. So you have a local repository, you have a remote repository always. The developers are continuously updating on the remote repositories. So where you will be updating the source code, consider that the developer updates everything in the remote, right? And then multiple developers may be updating the remote as well. Multiple things will be happening accordingly. Now, once you have done with these things, right? Once we have done with these things, now you do also have a concept of Git branching, but that is little advanced, which is not required for this course, right? So understand that in order to work with multiple parallel development, we go for the Git branching concept, but that is again not really necessary for the DevOps engineer also. DevOps engineer will never work on a branching concept. That is not at all necessary for him. So with that being said, team, I will stop with the Git here. This is all what we want to do with Git, right? So after this Git team, we need to understand, or this is where we see that. So this is where we see that, right? Basically, the DevOps engineer job starts. Once the development is completed, once the source code is available in the GitHub reference, you have it. So great. So if you want me to give the something called as Git Merge, so it is about releasing the code, right? When I try to understand everybody, the concept of Git branching is that whenever you want to work on the parallel development, right? Which I mean to say that, okay, consider that this is what I'm happening it. So this is what is something I'll do it. So consider that you have working on a project and you are ensuring that the project is done, the version 1, let's say that you released some version 1 code into the production environment. Okay, so here it is, production environment we call it, right? So this is what it is, right? Consider that you are running the version 1 in the production environment. Now, once the version 1 is done successfully, basically, so which is running successfully, but let's say that after that a client has given a development or next feature, you want to add something called as feature XY. Now, along with that, there were some defects reported in the version 1. You want to work on the defects as well, right? Consider that these are the two things which need to be worked in. Now, along with that, you see that feature XY can be released in November first week, right? But let's say that the defects has to be released next week itself, right? This is what the release dates that you have it. So in order to release these functionalities, right, the changes that you do it, in order to do this one, right? So in order to do this, right, feature XY or whatever it may be, in order to release these things, and I want to work on this parallel development also, because both are necessary. The feature development takes a longer time, definitely. The defects may take a long, so both the things are going in parallel way. Okay. Now, how do I make the release smoother? Consider that a developer one is assigned, say that my project leader or a team leader assigned him to work on feature XY code, right? Now here you have something called as this developer is assigned a work called as to work on the defects, right? There are two different developers assigned two different works basically. So this is developer two, so these are doing it. Now consider that they have cloned the same repository here, right? I see that my project, right? Now consider that here you have defects, right? Whatever it is, he has version 1. Now he started working on the defect code, right? This is what he does it in his local. Now consider that this guy is also working on a local, so he also made a copy of version 1 plus he is working on feature code here. Now consider that at the end of the day, everybody pushes to this one, right? Let's say that v1 is a version which we already released it. Now you have a defect code pushed here, right? And you also have the feature code pushed here accordingly. Now consider that this is the repository, I have it, and all the changes are available like this. Can I take this? Let's say that the defect is completed, defect development is completed, it was tested by the developer. Now we say that that is ready for the deployment, correct? Now can he take the code, like can we take the code from here and deploy it to the production with the defect release that the next week is arrived? I want to release only the defect code now into the production. Is it possible for me? What do you guys think? Is it possible for us? Can I take the code and release it directly here? If I take a clone of this project from this one, will I not get a feature code as well? Agree or not, team? So you get it right. So this is not a possible solution basically that you do it to make the releases smoother. To make the releases smoother, instead of this one, we normally go with the concept of branching, right? So which means that instead of doing this one, right? So this is what happens in your real life, right? So instead of this one, let's say that we will make a copy, or the developer will create something called as a branch. By default, team, the default branch is known as a master branch. Everywhere you will be seeing as a master branch, right? Like it is like a copy of the code under your repository. Consider that that is just a reference point, or consider that that is a folder. I have a master copy available. Now when I'm saying that I'm creating a branch, right, I'll be making a copy of my code and I'll create it as a branch which is called as feature XY. Something he will create it. So he will make existing version copy and then he will start working on it accordingly. Similarly, this guy would also create another copy which is a defect accordingly. But when they push it here, so right here they will update like this. There will be a 3 different copies will be available, right? Here there will be a defect and there will be something called as the feature branch will be there. So this one will have v1 plus feature code. Now this one will have a v1 plus defect code only, right? So in this case, team, I have a 3 different copies basically. Try to understand the 3 different copies. The master copy is just the version 1. Now there is a defect copy, I have it, which is version 1 plus defect code only. And there is a feature copy, I have it, which is also having the master copy version 1 plus the feature code, right? Now whenever you want to release, right, whenever you want to release, now what I can do is that I can directly take this feature branch, right, feature code, which is having a v1 plus defect, exactly what I wanted to release it next week. That is all I have it in this code. right? And I'll be releasing this into the production. That is possible for me. That is one way of doing it. Now, other way around is that people would merge, right? Because the defect development is completed. So when we want to release the things into the production, we normally see that we merge the branch, which is defect, into the master. Means that we merge the code from one into another one. Consider that defect is merging into the master. So master branch, a master copy becomes again v1 plus defect, and I would release the master branch into the production. Now, this is the idea. In order to make the releases smoother, in order to work towards the releases that you planned, we normally do not touch the master copy just to avoid the confusions on everything. So we normally created copies of the master. We work on the copies and we ensure that the release is made with that copies. And then once we're done with the release, we will merge the code into the master code again. So that is understanding of the merging that you need to have it, Vinay. Just on the theoretical wise, you can show you like this. I hope you are clear now on that point, right? So great. So that's all about it. We're not getting into the practical. Practical will take a longer time. Sorry that you don't have much time here. So consider that there is another question here. How can I undo our commits? How can I roll back? That is a good question again. So let's look into it quickly, right? So consider that. Let me give you a simple trick here so you'll understand it easily. There are certain commands again that you can do. Again, that will work only in the local. Consider that we had something called as work area, nothing but the one where you make the changes. Now you have something called as stage area where you add the changes to the Git repository. Then you have something called as commit area, right? There are three different stages that we had it in our local repository, okay? Consider that whenever you're talking about changing to this one, this is always in the local repo. Now, in order to make something right here, what do you do? It standard Linux command, he called as work area team. This is what is called as work area basically. Now you have this is called as stage area. Now you have something called as commit area, right? Committed something. Now here you move the code from one stage into another stage always. Now this is one stage and the second stage. So here we make the changes, right? Make changes, you call it normally. Wherever you make some changes, adding files, deleting files, that is nothing but your working area, we call it normally. So you're working under a folder. Project folder is nothing but your work area. Now, once you have something modified in the work area, if I want to move it, what command do I use it here? What command do we use it to stage the changes? What command do we use, team? Which I told you already. Add. Thank you so much. So we do something called as git add dot. So the changes that you make it will be moving on to the staging area. Now, once I feel that everything is properly done, I want to make a version history. Normally, I'll do something called as git commit -m message, something that will move from your work area to stage area to the commit area. So the same way you did it, team, if I want to revert a change, right? There are multiple ways that you do it. Revert, right? So the way I moved it, the way I want to move it back now, right? Now this is waiting. There are various commands. Again, this is one of the best way to do it. So I'm just showing you the best way. You can figure out the other things. Git reset -- soft, I call it, and with the commit ID where you want to go for it. So this is a command to make revert changes, which means that I want to move back. I want to delete a commit ID. Whatever the things I committed, I want to put it back to the stage area. This is where you do a command like this. Now, if I want to move the files from this stage area to the work area, again, you do something called as git revert. So not revert, right? Git restore, right? -- staged and the file name. So this is a command string that you would normally use it to revert or undo a commit what you did it accordingly. So let me show you that quickly just for your understanding. I have written here, but let's say that it is reset team, not rest. Sorry that the spelling is mistake. So here it is, right? Consider that if I do a git log, now I have these many commits, I did it. Now I want to delete this change in my local, right? That is what all I'm doing it. this is what you do it, right? Now I want to delete this, right? Which means that I want to delete this commit ID. Whatever the change happened here, we want to put it back, or whatever things happen. Or let's consider that, right? Touch new, right? hello.java. I moved it, git status. This is called as working area. You add the change, git add. This is the staging area, I have it, right? And you do something called as git commit, right? -m, right? Yes, whatever you do it, you do it. So this will be creating a log history for me, right? Now this is the new commit ID which I created just now, correct? So add the changes, stage the changes, make the changes, stage the changes, and commit the changes. Now, whatever the change I did it, I do not want this to be having a version history for it. Let's say that I want to delete this commit ID. So I'll do something here, git reset, right? Git reset --soft, right? That is the command I'm using it. Now team, if I want to delete this commit ID, which means I want to move back to this particular position, right? So what I have to do is that do not give the command, or do not give the commit ID which you want to delete it. Instead, it asks you where you want to go back to. You want to go back to this position, or this position, or this position. Whatever it is, it will tell you. If I give this one, which means you want to delete all these things accordingly, right? That is what the meaning of it. So let's say that here I'll give this particular commit ID, which means the above things will be deleted accordingly. Remember that, which is fdb something. If I do this one, it will set it. If I look at the log, now you simply see that the recent commit ID, which was fbd something, got deleted. If I also look into this git status, you will see the file again under the hello.java, under the work area, sorry, stage area. Now if I want to do this, git restore, right, hyphen staged, I call it. Now you do give this hello.java. Whatever I do this is what it will move back to the status of untracked files again. So this is the command. So this is how you would normally revert a change in your local repository always. So this is how team we make the changes, we track the versions, we push it, or we'll share with multiple people with the GitHub remote repository. Push, pull, clone, you do everything. Once after you do this one console, this is what all you can understand. So is it possible to go back without deleting the commits? Yes, that is also possible, Pandit. Now there is another command called as Git Revert. Okay, not about reset, but there is something called as Git Revert, which will not delete the commit ID, but which will delete the changes that you make it. That is another way of doing it. You may try that. Maybe just search for some command called as Git Revert. Please try that out. This is one way. There is another way. There are multiple possibilities which you want to look into it. Okay, so just an understanding for you. This is all about it. Okay, so coming back to this one theme, I hope now you got some fair idea, right? So let's say that the project that you are asking me so far, right, the changes. So where is that? So here it is, right? We already shared all these things, commands with you guys, Pandit, I'm sorry, Himanshu, and everybody. So we have all the commands here listed down for you, right? There is working with Git local. Now you have all the commands listed, which command does what, with the explanation also available here. Right, you have all the written documentation. Please go through that. Right, along with that, you also have the remote operations, a push, pull, everything. Right, everything is available here. Please do check it and follow the documentation to do all the things accordingly. Okay, so I hope you have all the commands. If you need something else, let me know. Again, we can do it accordingly. Okay, is that right, Imanshu? That's what you're looking for? Right, so you will have all of them. Please do check it after the session. So you'll be able, if not finding something, you can let me know. I'll add them accordingly. Okay, so that is about the basic Git team. So I'll stop here now with Git. Okay, now let's try understanding a few more things on the rest of the topics that I'd like to start right now. So here just for your overall view team, right? Now we understood that the developer would use the version control system to track the versions That is the responsibility of developer, not as a DevOps engineer. You may not look into the code versioning and everything. And let's say that your responsibility is to take the code from the GitHub or kind of a centralized management system where the source code is available, right? Now, this is your responsibility to take it and then start deploying this code into the various environments. So this is where we say that once the development is completed, this is where the DevOps engineer role starts most of the time. Not all the DevOps engineers are developers. Basically, they cannot write the code. We know that, right? But if you are a developer already, that is an added advantage to you. But if you don't know coding, so don't worry about it. You do not need to code it. But there is a lot of things once after coding is done that you would need to take care of it. You will be concentrating on those roles that will be starting now once we understood the basics of Git. So before we move on, team, I think we can go for a quick 5 minutes break, I believe, right? We will take a break for 5 minutes. We'll come back. We'll discuss about the next tool where I'll be starting with Jenkins accordingly. Is everybody okay for a break for 5 minutes? Or you do not need a break? Must need it. Okay, let's go with it then. So let's take 5 minutes. Please be back in 5 minutes. We'll discuss about the things after the break. Okay. Yeah. Okay, team. So I'm also back. Okay. So as most of you are back already, so let's get into the discussion team here, which is very much important. So please try to understand this, right? So we are talking about the source code being developed by the developer, and he will put it into a source code management tool accordingly. Now, once the development is completed, team, try to understand this is where mainly the DevOps role starts, as I was speaking. Now, just make you understand things, team. So let me open up a few things so that it'll be easy for you to understand everything. Let's see that. Okay, fine. Let it be. Now here it is, team. Our goal now is that we need to take the source code and then deliver it into the various environments that we were discussing yesterday also. You would have a multiple environments in any organization before you deliver application into the end user, like a production environment. You must put it into various environments such as development, QA, and then pre-prod, and then finally the production, correct? Now this is what all you do it basically, right? Can I take this source code and deploy it directly? Here is the question, correct? Can we directly deploy, team? Is that possible for me? Source code is a combination of n number of files, team, that you must understand. It is not a single file to take it directly and copy to a server and say that my application deployment is completed, correct? Now the question here is that how would I take this source code and how would I deploy it into the servers, correct? Now, for example, team, can I, or whenever you install a VLC media player, do you get an executable file or do you get the source code of the VLC media player and place it on your system? What do you guys do it? You normally get an executable file, right? That is the standard format that you get. It means if I want to install an application, if I want to install a software, normally we would have to have an executable files always, right? So without converting the source code into an executable file, this one I cannot place it onto a server. For example, even a web server, even it is a web application, I talked about desktop application, even if it is a web application that has to be deployed onto a web server such as Tomcat, right? So you will have a machine with a Java installed, considering that you're working on a Java based application. So you have a Java install, you have a Tomcat. I cannot copy the source code directly onto the Tomcat server. That is not possible for me. So I have to convert, right? I have to convert the source code into an executable format. That is what is expected right now. That is what we must do it. Okay. Consider that the goal is to deliver an application, but in order to convert, we say that we need to build the code, right? Build the code, team, build the code, which means that basically converting the source code into an exe format, basically we call it, right? So this is the process, team, that we need to work on right now. The immediate things, once an application is developed, once multiple developers keep on doing the changes, these have to be done. So how do I build the code, right? How to build the code is the question, right? Now this is where, team, we use something called as build tools. Now the build tools, for example, there are various different types of build tools. We have it. Now consider that there are many tools. If you are using a Java based applications, you have a build tool such as Maven and or a Gradle. So there are many tools that you have it accordingly, right? Now if you're using a .NET based application that you normally get it, let's say that Visual Studio Code, right? VS Studio, you have it, or MS Build that you have it. There are various types of tools again. Now, when you converting this code, team, it is not necessary that you always have an extension as a .exe file, right? Within your Windows, you might see that VLC media player.exe, or you might be seeing the different executable files such as .msi files. So based on the programming language, again, based on the things you use it, the extensions may have different things, right? But they are also executable files, such as Java files or Java applications usually have an extension of .var or a .ear or a .jar file. These are nothing but an executable files format of your Java code accordingly. For example, in the .NET based things, you will get a .dll file or a .exe file or a .msi file. This is extensions I'm talking about it for an executable file. So which means that my app.exe or my app.war file, like that, right? You will get the things according. So based on the different programming language, again, you would have different build tools and different extension for executable files will be possible again. So now in our case team, we will be working on the Java based applications. I'll be giving you a source code on which we'll be implementing the entire tools accordingly again. Now consider that here we are using a build code process or build the code that is necessary. In order to build the code, I need build tools. So we will be using a tool called as Maven for our build process. So we'll be using this one. So Maven is something, use it. Now there is a process team, we call it. So build code, we have it. So build process that we have it. Now build the process is something, there are various stages team, we call it. Various stages are involved in it. Various stages that we use it normally. Various stages involved in build process always. Stages or steps that you call it always. Now build process is not a simple step to perform that, to convert the source code into an executable file directly. Of course you can do it, but there are industry standards. There are industry standards, we have it, to follow the build process methods or build process methods, you have it. Now consider that there are various steps involved in, or stages you call it already. So the first stage is that you will be doing something called as compilation, right? Compilation, you do it. Second thing is about a code review process, right? Now the third thing, and you may do various stages, team, depends on the project, depends on the things. For example, in our case, we will do the compilation, we will do the code review, you will also do the packaging. That is what you do it. Packaging is where normally we call it getting an executable file. We can do it. Consider that you may do a different types of things also. Code coverage part also you can do it. Code review, code coverage, unit testing. So there are many stages that can be done. For example, in our case, we are doing only 3 steps. As I said, like you can directly package it. I'm saying that you can directly convert the source code into a executable file. That is possible for me, but implementing this process would help us making a stable application in the production. Means that before even packaging the code, before even converting the source code into an exe file, if I try to identify if there are any mistakes in my code, then it would help me to run my application smoother into a server, or the end user can have it easily using a connector, right? Now we'll try to understand the compilation. I hope you guys know about it, but let me write it quickly. So the compilation means that converting, right, the high level language into machine language, right? We call it this one, means that you are converting the Java program into a bytecode. So the Java program or the machine would understand only the bytecode, not your programs basically. So we must ensure that that is compiled successfully, or the programs can be compiled so that machine can understand what you are asking to do it. So that is where we normally do the compilation. So the compilation is successful, then only we can go for the next levels. Packaging also makes sense for me. Without that one, I cannot do anything again. So that is mandatory here. Okay, compilation is mandatory for something. There are some interpreter languages where you do not need it, but this is mandatory for Java, at least for compiling the source code into a machine language. That is mandatory. So that is what we do, a compilation. If compilation is successful, then only I can go with the rest of the steps. Otherwise, it is waste of doing the rest of the step here. That's what I can tell you. Now the code review process team, code review is just like a review of the source code line by line. Like I'll open your program file, what you write it, like that is in an example. If I write an essay and I ask you to review it, what do? You will go through each line by line. You will try to find if there are any mistakes, like spelling mistakes or grammar mistakes. Are there any full stop, the sentence formation mistakes, or whether you have written as per the standards or not. There would be some standards to write an essay basically. So you would try to identify those kind of mistakes, right? There is a possibility that the developer may do some silly mistakes sometimes, missing out some parentheses or a comma, or which is required to write in your code, right? So that kind of a mistakes. Along with that, so you might have to have there are certain standards to develop an application, right? I cannot blindly write a program and say that this would work absolutely fine. No, there are certain standards designed by the various peoples or based on the experience that they had it so far over the years. Now there are very much rules defined it. If you follow those rules, your application will be a stable application in the production like environment. So you are validate the code against standards, right? This is what we call it. This is what is the process of your code review, we call it. So validate the code against the standards of development, a Java application development, what we call it. That process is necessary again. This will really help us, I'm telling you honestly. This identifying the issues like this in the source code before even you're delivering it to the end user, which will help me maintain my application stability 100% in the production like environment. That is mandatory again. Now, if you feel that you are good with these steps, if you are good with these steps basically, then you go ahead, right, and then you do something called as packaging. And packaging is nothing but converting the source code into exe format. Simple, that one. So I can directly convert it, but before I convert it, I'm validating my code. I'm trying to identify so that that would not really cause me the issue in a real environment accordingly. So this is the process team. You have a build process. The build process may have different stages also, where I've listed only 3 stages here. Based on the projects, people may have more stages or more number of validations that they do it before they package the code. That is possible, but the final goal of a process or a build process is nothing but converting the source code into an executable format. That is just an understanding that you need to have it here. Okay. Now with this understanding team, okay, so far I told you we need to build the code. In order to build the code, we need to build the tools such as Maven or anything. That's great. Now there are certain standards to follow the building the code, nothing but build process we call it. There are various stages in the build process code, right? Now consider that what is the role of Jenkins so far? Now what is the role of Jenkins here, right? I did not talk about Jenkins so far because I thought I told you I will be starting with Jenkins, right? But I did not talk about anything on the Jenkins here. What is the role of Jenkins in this process, right? So try to understand team, the build code process is a combination of multiple steps. Consider that I need to get the code from the GitHub, means I need to clone the repository, then I need to compile, then I need to do the code review, then I need to package. There are various stages. Now, if there is a failure happens in the code review or a packaging steps or a compilation step, you would have to report it to the developer through an email. Whatever you do, you have to do it accordingly. So consider that team, there are n number of tasks that you are doing it manually, right? A manual thing is that happening here. Now build tool or Jenkins is a tool team which is called as your build automation server, right? Now consider this one team, that's okay. This process is still fine for me, right? Whatever I'm doing it here, the various stages I told it. So there is still for me, which is good only, but how many times you would do a build in a single day? So how many times we need to build the code, right? That is what it is. If it is a single time task, I'm absolutely fine with running all those steps once in a day. I do report it back to the developer and I sit my idle. That's okay, great. But as per the standards of the DevOps team, we are expecting to build the code for every commit, every push that happens to the centralized repository, nothing but the remote repository. So it is a better practice that you would continuously build. Whenever there is a push happens, you build. Let's say that if the developer makes a 20 commits in a day, we recommend that you need to build or we need to repeat the same process for 20 times in a day. So repeating the same process 20 times in a day definitely makes you bored, or you might miss sometimes, that might miss the quality of the product again. So in order to make this a repetitive process, we say that we continuously integrating the code and continuously building the code in a single day multiple times. Continuous thing is added here. You have to make it continuous. Not sure how you do it. Now that is waiting. We need a server or a build automation is required. Now the Jenkins is called as a build automation server. It is also known as your continuous integration server, right? This is what the purpose of a Jenkins team here. Now the Jenkins is a tool which will help me, right, to talk to the GitHub and then get the source code automatically. Now it will help me build this step-by-step process. Means it will take the code, it will compile it. If it is good, it will move on to the next stage. It will do the code review. Okay, if it is good, then it will move on to the packaging. If the packaging is successful, okay, that package is good. Send me a notification, send the notification developer, all good. Great, job is done. Multiple times, how many times you do it doesn't matter. Jenkins will automatically run everything in a sequential manner. Now that sequential execution of steps is also known as your pipeline, right? We call this as a continuous integration pipeline, also known as a CI pipeline, we call it. The CD pipeline also need to be implemented, but understand that a CI pipeline, right, goal, right? CI pipeline goal is to convert or is to get an artifact. Now don't confuse with the name team. Artifact is nothing but an exe file, that executable file that I'm talking about it. That is nothing but we also call it as an artifact in the terminology, in the general terminology of in your organizations. People call that we are generating an artifact from the source code, which means that they are converting the source code into an executable format. That exe format is also known as an artifact in your organizations, that if you are already aware of it, right? So this is what it is, team. And remember that the continuous integration pipeline goal, whatever it is, doesn't matter. Whatever it is, doesn't matter, whichever the language it is. The continuous integration pipeline goal is to get an artifact or convert the source code into an artifact or exe file and make it available for the deployment. That is the goal of your continuous integration pipeline, whatever it is, right? The pipeline here we're calling it because we have a series of steps which are executed in a serial fashion, right, one after the other. That's why we call it as pipeline getting created. So multiple pipes are attached to reach the destination from the source. Source is the source code. From there the destination is that to reach or convert that into an executable format. That pipeline, that sequential steps are calling as continuous integration pipeline steps accordingly. Okay, now this is what all you can understand about it. Okay, so anybody have any questions, team, so far here until this one? What is the role of Jenkins? Why do we need Jenkins here? What is Maven, right? What is that we need to do once the source code is available? Anybody have any questions here? Can you suggest the different build tools for different languages like PHP, Node? Okay, I'll make a list and I'll give you the things, Pandit. So we will try to utilize the time here better. So I'll make a list. I'll put it under the GitHub repository. You may check the document there for various tools where I'll be doing it accordingly. Okay. Great. So this is something, team. This is something that you need to have an idea, right? So this is where we need to work with Jenkins. So Jenkins is again a build automation server. Again, Jenkins is just a dummy tool. So what we'll do is that, so Jenkins, right, we will integrate, right, tools integrated, right? Jenkins cannot do anything alone, team, here. So Jenkins cannot do anything alone here, which means that Jenkins will work with Maven to build the code, right? So Jenkins will be integrated with Maven. Jenkins can be integrated with Git. Jenkins can be integrated with Java so that it will do the necessary task. Again, try to understand Jenkins is just an interface, right, to integrate various things into one system and make them work as a single system again. So Jenkins is not directly doing all these steps for you. Jenkins is collaborating or bringing all the tools into one single place and helping you to build the tools and necessary pipelines accordingly. That is the purpose of your Jenkins here. So Jenkins by default cannot do anything. You have to make it to use it accordingly. That's all the understanding. Is Jenkins platform independent or programming language dependent? Good question. So Jenkins is platform independent. It's not dependent. Means that Jenkins can be run on your Windows or Linux, wherever you want to run it, just like your Java. Java is platform independent, right? So because Java means Jenkins is developed on Java itself. Jenkins is a tool, right? Is a tool developed using Java. So just like your Java is platform independent, you can run the Java anywhere. You can run the Jenkins also anywhere, wherever you want it, like on the Windows machine, or the there you want it, you can do it according. So what you're talking about using Jenkins, can I implement the projects, or can I build a pipeline for .NET project? Yes. Can I implement a pipeline for Java project? Yes, you can do it. Using Jenkins, can I implement a CI pipeline for Python applications? Yes, you can do it. So using Jenkins, you could do anything. Doesn't matter for it. Just to run the Jenkins, you just need Java accordingly. That's all about it. So using Jenkins, you can integrate any code, any type of a code from anywhere. Various source code management tools can be used. It can build any type of a code. It can integrate with any type of a build tool, right? You can integrate MS Build, or you can integrate Maven, you can integrate anything into this one, and Jenkins will work with that tool as necessary again. Okay, can we so let's say, can the Jenkins with other programming languages than Java? That's what I'm telling you, Pandit. Yes, it will. It doesn't matter, but just to run the Jenkins, you have to have Java on your system. That is mandatory, because Jenkins cannot work without Java installed on your system. Okay, so I hope I answered all of your questions, team. Now I believe you have some idea what exactly you have it. So let's get ahead and then start working with Jenkins, team. That is what all we're going to do it. So consider that I'll be giving you the instruction again now. Go to your repository, which I shared with you all, right? Go to the Jenkins folder. So under the Jenkins folder, you have all the instructions how to do this one: install Java, Jenkins, Ubuntu, and everything here. So here I have the necessary instruction to install Java, to install Jenkins, to install Maven. Everything can be there. So because we have to have all these things to be installed on a server to start working with Jenkins accordingly. So consider that I'll be installing the Java first of all. Say that sudo, right? I'm using the same server team. I do not need to take another server. So I already have the Git. So I'll be just installing the Java right now on the same server that we worked on so far. Just use the same Linux commands again to install the necessary things. All right, we are adding a repository from where I can download some OpenJDK software. I'm just hitting it, so validate the connectivity to the repository. Now, once after that one is done, you just install the OpenJDK on your system. So this command will get execute only for Ubuntu 18.04. This command can work across all the Ubuntu distributions, means that 18.04 or 20.04 or your 16.04 also, but it should be specific to only Ubuntu operating system. Any version of the Ubuntu, that is fine. Okay. It cannot be used for CentOS or Red Hat systems. No, that will not work. So what is the difference between Oracle Java and OpenJDK? Oracle Java is enterprise Java. Oracle will do a support for that Java. OpenJDK is like open source again. That is the only difference that you'll find it. Or Oracle may add their own libraries to the Oracle Java that they supported. They will give the support, and separate libraries are given to you, which may need it to run your application. That is the only thing. Okay, so that is what it is. So I have installed Java team successfully. Now let's say that a Java hyphen version, I'll do it. So which we are working here. So which is Java 1.8 is what I installed successfully on my system. Okay. Now consider this one team. Once I install the Java, I can go ahead and install my Jenkins on my machine. So let me run these instructions to install the Jenkins software. Now, how do you access an application that is running on a system team? Do you guys have an idea about it? How do you access an application that is running on a server? Anybody? Using localhost. If you are running in your Windows, you can use the localhost Pandit. Sorry, Himanshu, right? But consider that if I'm running on a remote server, then I might use, thank you, Gurunath. That's absolutely correct. Right, so fantastic. Most of the people don't know, so let me do this. Okay, installation has no candidate here. Try to understand, team. We are trying to get some mistake here. Look at this, it's writing a Gpg error has occurred, right? Look at this, this is what is nothing but you need to look at it clearly. It says that Gpg error basically, which means that there is some issue with this particular key, right? There is some issue here, so let me look at that. Do I have, okay, so I'm following the second instruction, team. You have to remove this. Don't use this first instruction, team. You must use the second ones, which is a long-term support release. Try to use these instructions, okay? So let me run these commands instead of the previous ones again. I think so. Jenkins has changed something in recent, so this is what is needed for you. So you just need to copy this command and paste it here. Right, once that is done, just run the sudo apt-get update. If not, I'll show you the necessary commands from the necessary things. Okay, this seems to be good. Okay, this seems to be working good, team. This is where it sees good only. Hit, and everything is good. Let's see that. I'll try to run the install command right now. If not working, then I'll check it again. I think this time it is proceeding, team, without any issues. You can see that it is working fine. So which means that, team, please use the second set of instruction, which is a long-term release one. These instructions are not working, so please do not use this one. We will update the document here, so don't worry. So use the second instructions that you have it accordingly, okay? Just for your reference again. Now your team, try to understand that a Jenkins is a server, or Jenkins is an application itself that will be accessible from the browser, but you must use it, right? Jenkins is a process team that runs on your system. This now, team, no issues here. Let's say that here ps-ef grep Jenkins is a command which will let you know the Jenkins process is running or not on your system. We installed Jenkins successfully, and we see that Jenkins is running successfully on my machine. Okay, now consider this one, team, here. Right, your Jenkins will be by default listening on a port number called as 8080, which means that if I want to access my Jenkins, I need to use the IP address of this machine, right? So localhost will not work here. This is a EC2 instance that is running on AWS data center. So you are connecting to the server over the internet. So you must use the IP address of this particular machine. This is not running on your Windows laptop. Okay, this is running in somewhere AWS data center. So we need to use this one. No need to install the Tomcat. That is not mandatory here. Without installing Tomcat also we can run it. That's fine. So here it is. If I want to use that, right, so I'll just use my VM IP address, which is a public IP. This is the one. Now I just need to take this one thing. Okay, take the IP address of the VM, right? Now you just need to go over this one, go here and hit 8080. That is what the port number. You just need to hit it. Now this will launch your application automatically, or a Jenkins application. which will be launched by default. So there are multiple ways of setting up the server, Gautam. This is Gurunath, I'm sorry. This is one of the ways or easiest way to set it up. The Tomcat installation is that the second way of setting up. You can do it. You can do that also. That's what I'm saying it. You can do that also. That is even possible, right? Jenkins is also Java application, as I told, right? You can directly run it using your Java, or you can install it on a web server also. That is even possible. So you may approach that also. This also, it is the same thing. Okay. You will see the same UI, same thing working way, but that is managed by the web server in a different way. That's all about it. But this is also good. Try this one also. It will also help you. If you already know that, that will also be great, not a problem. Now, once you understand, team, that we installed Java, now we installed Jenkins. Once you install Jenkins, you should be able to log into the Jenkins console. So there is by default, team, it requires an administrator password, which means that you need to find out this password on your system itself. Now this is where it is giving you some path, which is var lib Jenkins. This one we call it as Jenkins home. Under that there is a secrets folder, and under that there is an initial admin password file that is available. So copy this path, team. You just need to copy the path here. Right click and copy it. Go to the server and hit a command called as cat, this one. So you will be able to see the password, which is this one, the password. Now once you have the password, go here and put it. That's all you need to do it, and continue. Now here, team, it will take you to the next page where you will see something called as customize Jenkins with the default suggested plugins, or select the plugins to install. We haven't discussed about a concept called as plugin here, but I would recommend you to go with the install suggested plugins, which is necessary to work with Jenkins smoothly. So let's click on install suggested plugins. Now, once you click on this one, you will be taken to the next page where Jenkins will try to set few things on your Jenkins machine, right? It will try to install some necessary tools that is required to work with Jenkins, right? So once you have set this up directly, we can log in to the Jenkins console, right? It will ask you to set up a username and password as well, so that the subsequent logins can be used with the default username and password accordingly. So we are done, team. So here it is. You can see that it is asking you to create a first admin user. Now here, team, it is recommended that you keep the simpler one if you're using for the first time. So please keep it as simple as possible. So I'm keeping it as admin and admin. So I'm using this, and here I can give the name so that it will be easy for me to remember, like this. If you forget the password, team, you may not be able to log in later. So of course we have a way to disable that, but ensure that you enter simpler things and remember the things accordingly. So save and continue. It will take you to the page where it will ask you the instance configuration. Leave the details as it is and save and finish the things. Now this is where you see that your Jenkins is ready to be used. Now let's say that I start using Jenkins. Now we are ready with the Jenkins console, team. I'm not sure if you ever accessed the Jenkins console in your organizations, right? So this is how you normally set that up, right? Once you have your Jenkins is ready, right? Once we have the Jenkins is ready, we can simply do it accordingly. Can see share the path again for the Jenkins password that is available here. You can see that I'm giving you the command directly. Every time you see this, you can hit this one once after you install it. Here you go. Okay. So here it is, team. Now you have the Jenkins server ready, which is running on the backend. Now you also have the things which is ready on the front end. The Jenkins UI is also ready, with which we will be able to set up the necessary things, right? Now along with that, team, we also need Maven. So Maven also to be installed on the Jenkins server. That is mandatory again. So let's go ahead and install the Maven also on my system. using this instruction at this one bottom. Install Maven, that is required here. So let's go with this. I'll run the certain command here to install the Maven on my Jenkins server, right? So that which we can implement it accordingly. So I'll just copy this command. So here it is, team. I'm installing Maven, right? This is what it is. So I have installed Maven, team. Consider that we have installed Java. You need to know the Java installation location. So by default, team, if you follow my instruction, the default installation location of your Java is this user lib jvm, right? Under that you have a Java 8 something, whatever it is, right? This is the path, team. You can consider that this is where you will see your Java location, Java installed location. Now you also need to know the things pwd. This is the path. Now you also need to have an understanding about Maven installation location, which can be called as your Maven home. So I installed under opt. Now this is the opt Apache Maven is the location of your installation. Means if you follow my instruction, team, these are the path where you see the installation locations of your Java Maven, and you also have a Jenkins installation location. We also call it as Jenkins home, which is under var lib Jenkins, right? Here you see that the Jenkins content will be available. So you must be aware, team, because you are the one who's setting up the server. You must be aware of what are the things that I can look at the back end to troubleshoot some issues with my server issues again. So I'm just giving you the path so that you would have to remember these things, where you can see the necessary things accordingly to work with the things, right? We can use any Java version, right? Yes, of course, you can use any Java version. Absolutely, that is possible. So is there any need to set up a Java environment? If you are using multiple, right? So let's say that it is okay to set up a Java environment. If you want to make use a Java environment variable somewhere in your project, you can set up a Java home. Otherwise, it is not mandatory again, Guruna. So better to set it up if you want to utilize it. The environment configurations also I have given here, right? So environment variable configuration also I have given. If necessary, only set it up. Otherwise, it is not mandatory. So I'm not setting up here. If required, just set it up using those commands. Okay. Right. So with this understanding, team, now we have our Jenkins console ready, right? As you can see that my Jenkins console ready. Now the only thing is that, team, I need to integrate my Jenkins with the various tools first of all, right? Because without integrating, we are thinking about creating a continuous integration pipeline using my Jenkins. So Jenkins should be talking to the Maven to build the code. Jenkins should be talking to the GitHub to get the code, right? So how it can communicate with various sources, right? Now that is where, team, we say that we need to integrate the tools with Jenkins, right? Now this is nothing but a configuration settings that you do it on your Jenkins server, where it can locate the Maven installation location or a Java installation location like that. So whenever you think about configuring something to the Jenkins team, we say that go to the manage Jenkins option. Now the manage Jenkins option is just like a settings button on your phone. If you would like to configure anything to with Jenkins, right, we will normally go to the manage Jenkins option, where it will allow me to configure various configurations on my Jenkins server. In your organization, if you may not have access to these things, most probably. If it is a Jenkins administrator, you will be seeing this one. But if you are as a normal user, you may not see all these options, provided you need an access level, right? We can control the role-based access on the Jenkins. Normally, the Jenkins administrator will give you unnecessary permissions only, but not a full administrator privilege. But this is like a full administrator privilege that you have it, where you will see n number of options with which we can configure various things. Now, as I'm telling about, we need to discuss or we need to integrate Java, everything with the Jenkins. So here I go for a global tool configuration. So click on a global tool configuration. Now under that, you will have a necessary configuration steps to configure the JDK. click on JDK. It will pop up this tab here, JDK installation. Now it is asking you to install automatically. I do not want to install automatically because I already installed my Jenkins Java. I'll deselect this one. I'll name my Jenkins Java 1.8 I call it. Now I'll give my Java home path, right? So where is my Java home path here? That is where I've shown you just before. The Java installation location is called as your Java home path. So this is my Java home, which I selected, which is user lib JVM Java 8 open JDK, the path, right? I'll just give that path here. So Jenkins will be able to detect that the Java is installed on that location. Now the Git is by default configured, but if you would like to know the Git installation path on your server, you can just do which, right? Sorry, just give me a second. Just give me a second, team. My server is not responding. I don't know why. This is strange. Okay, great. It is not at all responding. It is very slow. I don't know why. Now you can type a command called as which git team. Right, that's what I feel it as well. But when you say which git, basically it is just throwing this one, right? The path where you have the git located. Now consider that you're going to configure this path, or you can leave it as it is, but let's say that I'm configuring this one. User abed get is my git installation or path to my executable. Now once you have done this one, as we said, we're going to work with Maven as a builder tool. So there are multiple tools here available already. So here it is Maven. So I'll add Maven here. Now here also it is asking you to install automatically because I already installed it. I do not to install again. So I'll deselect that option. I'll say that Maven 3.6 I do it. And I'll put something called as Maven home here, which is nothing but the path that you had it earlier, which is this one, right? At the location of Maven installation. Now that is where we just take this one and set this up, right? Now you have to save this configurations. That's all you need to do it. Save the configurations. Now once you're done with the configurations team, we will come back to the Jenkins main page. Now within the Jenkins team, we say that if I want to give some instruction to the Jenkins, means that as I told team, Jenkins is just a dummy tool, right? Jenkins is just a dummy tool basically, which does what you say to do it, right? What you ask to do it, it will do it according. If you ask to kill a server, it will go there, it will kill a server also. That is how it works. So you have to instruct the Jenkins what it has to do it, right? Now that is where team, whenever you want to give some instruction to the Jenkins, we go to the item called as new item on the top. Click on the new item. That will take you to the next page where it will ask you various options like this. Sorry team, so I'm here. So here it is, where it is asking you to enter some text or the automation name or a job name you call it. Now you just enter the job name here. Consider that you have a job 1, which is compilation. This first step as part of the build process. We say that I want to compile my source code. Now I'll select a freestyle team. Freestyle will let you do what you want to do it. Now you select a freestyle here and say OK. Now when you say OK here, right, it will take you to the next page where you can configure a certain settings under your Jenkins, right? Now Jenkins here team, you can see that. So first section is about a general section where you can enter some description about the job, what this job about it, how to manage this job and everything. Apart from this one, if you go to the second section where it is talking about the source code management, nothing but the source code management tools such as GitHub, you just expect, or it just expects you to give the GitHub URL where your source code is present, right? Now here I'm just taking the Git option, click on the Git and it will ask you to give the repository URL. Now this is where team we will be working with the real-time project. Consider that I have a project here, so which is a sample Java application. I'm giving this project to you guys, so please start making use of it. You may make a copy of this if you want it as well. That's okay. Now you can see that here the repository, nothing but you have the source code available completely. Look at this one team, there is a source available here. Under that you have main. Now you have the DevOps demo and utilities. Yeah, and you will see all the application Java source code completely developed, and it is ready for you accordingly. So we will be executing this project to understand various stages of your DevOps model, right? Right now we are under the build stage where we are trying to convert the source code into one executable file. That is nothing but we're going to do it with Maven again, right? So I'll take this URL team, whatever the URL which I pasted, and I'll go here to my Jenkins job and I give it here. Now that's all you need to do it, with which Jenkins would understand that, okay, I need to go to this repository and I must clone this particular repository, right? So that's what Jenkins is going to do it. Jenkins make use of Git installed on your server. So it will do a Git clone to the remote. So Git, the entire repository will be cloning onto your local machine or the Jenkins where it is running accordingly. That's what it does it. If it is a private repository, you must have to provide the credentials to go through that. If it is public, you do not need anything. And I'm taking the default master branch, but this is where my source code is available, or that is the branch that I would like to release into the production always. So this is what it is, team. I'm taking it out. Now, after this one, I'll go to the next stage, build environment. There is nothing to do it. Build triggers is a way to automate the process, team. Means when should this be triggered, right? Now, as I told team, this Jenkins or this job should be triggered. It is a sequential order. So whenever there is a push happens to my source code, I must take the code and I must compile the code immediately, right? That is what the process. So this is where you automate the things to do it according. So this is where team build triggers will help you to automate it with various steps, like build periodically will help you to build. Periodically means that every 2 hours there is a build, or every 3 hours, or once in a day, or twice in a day. That is the option you have it called as build periodically. You must put a cron schedule. If you are aware of the cron tab in Linux, that is the same schedule goes in here. If you're not aware, forget about it, not a problem, right? So but otherwise there is other option which is called as your GitHub hook, right? Which means that GitHub hook is the team. There is an event that will be generating on your GitHub itself whenever there is a commit happens. So this job will be triggered automatically based on a push happens on the GitHub. So how does a GitHub can inform my Jenkins that there is a commit, right? That is, again, we must understand it. Consider that I selected this option, which means that it is listening to a GitHub somewhere. GitHub is trying to communicate with this job accordingly, right? Now, how do I configure that is that team? Try to understand. It is very simple, but look at it. Now I'm going to configure my project settings. Okay, this is my project basically. Now I go to the project settings. If you want to implement this one team, you must make a copy of this project into your GitHub accounts. Please do create and make a copy. That's all you can do it. So go to your project settings. Once you copy to your account, then you go to the project settings. Now under the project settings, there is something called as webhooks. So this is where we configure a webhook like this. Now we do it. Now you can add a webhook here. Consider that you are adding the webhook. So here it is asking you to give the payload URL, nothing but your Jenkins URL that is expecting it. So it would trigger, or whenever there is a commit happens here, this will let Jenkins know that, okay, there is a commit, you trigger this job. Whatever I configure with GitHub here, the Jenkins or GitHub will trigger this job automatically. Okay, that's all it is going to do. So I'll do is I'll take this job URL, my Jenkins URL. Now I'll give it here simply, right? And let's say that here I'm going to put something called as GitHub webhook, right? This is what all I do it. This is what I just need to append team at the end, and there is a slash at the end is mandatory again. So this is what you need to do. The Jenkins URL, the Jenkins IP address, and the Jenkins port number, and slash GitHub webhook. This is what to intimate that the job basically wherever it is configured a GitHub hook. So it will intimate that one. Now this is what it is. You need to do it. Now once after this one is done, on which events would you like to trigger the webhook? When this webhook should be triggered by the GitHub automatically. Now that's where let select an individual events. Now we'll be checking about a push event, means somebody pushes the build. You have a push. There is pull request or pull request review or releases. You can choose based on your type team, but this is what all you do it. Then so that I'm selecting pull request, right? Pull request reviews, and then you choose anything that you wanted, but the push must be there here. Rest everything is an optional one. Okay. Now that is done, and then say that add webhook at the bottom. Once you add a webhook here at the bottom, this GitHub will try to communicate with Jenkins. If it is able to communicate, it will mark it as right, which means that this is able to communicate with my Jenkins right now. It is looking good for it, right? Now, once you have this one is good team, good, this one is good. What I'll do is that I'll come back here. Now, okay, great. You have given a project URL. This project is going to trigger this job automatically based on the webhook that we configured it. Now, what exactly you want to do with this particular job is nothing but compile, right? We need to do a compile. So I need to give that instruction still. So I'll go to the build step. Now I'll go here and I do something called as invoke top level Maven targets. Nothing but I'm asking you to use the Maven. I'm asking Jenkins to use the Maven that I configured it. And I'm asking Maven to do certain task, which is called as compile. So internal team, the Jenkins would trigger the Maven. Maven would trigger the compile process. It will generate the necessary results if there are any things need to be done according. So I'm just giving this Maven 3.6 and I'm giving the compile, which means that Maven is going to compile my source code accordingly. So let's say that save it. Once I save it, team, this is how you would build some jobs in Jenkins. Like job one is what we build it. Likewise, we can create as many jobs as I wanted in my Jenkins console. You may create multiple pipelines, multiple jobs, multiple things to be done accordingly. Whatever you want to configure, you can still configure it accordingly. So here it is, team. Once you created a job, we just have documented the steps what I needed, but we haven't executed them yet, right? Should I execute it or should I make a change? Here is a question, right? As per my configuration, whenever there is a commit happens here, that's when it should trigger. You can see that right now you see the build history, nothing but how many times you have built it. Or let me build it manually first of all, then we'll go and look at the automation also. Now let me build an team. Whenever you think about running this job, the instruction, let's say build now. Just click on the build now. It will start executing the jobs that you do it, right? So you can say that here. Now it is doing some necessary things. Look at it. Same thing related to Maven and everything. Maven is performing all the steps for you. Here it is, team. Look at the output here. See that? You can see that it is started by the admin user, right? And it is building the workspace in this particular location, which means that, as I told, Jenkins is cloning the repository. So where exactly it is cloning on the server is somewhere it should have a disk location, right? So that is where, team, you can think that the repository is getting cloned under this particular folder, which is called as your Jenkins home, we call it. Right, whenever you build anything on the Jenkins team, it always goes to the Jenkins home, which is where lib Jenkins, as you see it on my server. Now under that there will be a workspace folder. You can see that there's a workspace folder that gets created, right? Workspace folder. Under the workspace folder you will see the job that you created which is job 1 compile. Now here team, you see that the entire source code got cloned, means that whatever you're seeing on the folder or a GitHub here, whatever the entire content that you see, it entire thing got cloned, entire repository got cloned on your server except the target directory. Rest everything is from your GitHub that Jenkins has cloned onto your system. Now Jenkins will always clone everything under the workspace folder. That is where it will execute all the commands also accordingly. That is a basic understanding. Now once you have done this one team, let's say that here there is a target folder. Target folder is the output of your compilation process. Okay, whenever Maven does compilation, it will give you some results whether the compilation is successful. If the compilation is successful, the bytecode of the Java code, means the original Java code, will be converted into a bytecode that we normally call it as class files, right? That will be there here. So for example, the same content can be seen from the console also team. So here under the Jenkins console, you see that it is trying to clone the remote Git repository, right? It is trying to do that. Now after that, it is also trying to run a command called as maven compile on your system. Whenever it started this one, it's scanning the projects and it started building the code, whatever it is, compiling the code, not building the code, just compiling the code. Now under compilation, you see at the bottom that it is successful, right? Build success, whatever it is, the first stage of the build is successful here, the compilation, which means that I can proceed further with the next set of steps accordingly. So consider that here it is compiling 13 source files to class files. You can see it, there is a classes that is getting generated, which is nothing but the bytecode team, means converting the source code into a bytecode so that machine can understand that. As part of this conversion, if there are any problems, right, it will throw errors also that will be there, right? Let's say that here it is cd, see that entire repositories or all the results will be available. Com, you see it, utilities, under that you will be seeing all the class files which are nothing but a bytecode that we may not understand it. Okay, the machine would understand this one, but you may not be able to understand easily. That's what you see it. See, it is not understandable. That's how it looks like for you. Okay, so that's how you need to understand about it team. That's what is the process of compilation, we call it. Okay, so what Maven exactly does here is communicating between Git and Jenkins. Maven is not communicating with Git and Jenkins. Basically, Maven is the one which is converting the source code into an, a compilation, or compiling the source code, we call it. So Maven is doing its own job. Jenkins is using the Maven to convert the source code into an executable file accordingly, right? But as part of it, we are not directly converting into an executable format, which is actually reading your source code and converting the Java code into a bytecode. Does that make sense? Right, so great. So Jenkins is using Maven, or Jenkins is using Git. First of all, Jenkins using the Git, it is cloning that source code into your system, and Jenkins is using Maven to convert the source code into a bytecode. First of all, that is what is the compilation process. So that is what is understanding that you have it. Great. Now this is what you do at the step one that is completed successfully, right? Now we know that we have configured this to be running automatically also. Right now I executed manually. That's where you see the build history, means how many times you have built this job in a day. If you look at the console output, you will see normally called as started by the admin, right? But let's say that I will not run this time. You will see the one number only here. Now let me make a change here. In simple words, I'll go here, I'll modify the readme.md, right? And I'll put a commit here, just adding something here, and I do a commit the changes, which means that I just do a commit, but I configured something on this project. Whenever there is a commit happens, this should trigger automatically. Let's wait for a minute. Can you see this is triggered automatically now? Did I trigger this? No, right? So this is automatically triggered the second build here. Whenever there is a push happen here, it automatically run this one. Now if you click on this one, look at the output. Now you can clearly see that it is started by GitHub push by the learn DevOps, right? Now this is what we are expecting now, so that now you do not need to watch over when the developer will be pushing it. You just automate the stuff, you sit back and enjoy your things, and then ensure that this pipeline is getting successful. In case of a failure, you would get notifications and you know to start building things and fixing the things accordingly again. Now that is what is your duty, team. As a DevOps engineer, you have to build this continuous integration pipeline, integrate various tools with Jenkins to work as a single system, and build your continuous integration pipeline at the first. Am I making sense? Are we clear up till this point, or you have any questions till this point? Can I have, is there any questions that I can answer it? Okay, great. Now you have this process understood, team. Let's create the second step, which is going to be your, or I think we already crossed the time. Is it okay for next 10 minutes for you guys? Or do you want me to end it here? Is it okay for everybody, team, 10 minutes more? Okay, great. So then let's proceed further. So let's create it, the second job, which is going to be your code review. Let's say that a new item. Let's say that I'm going to do job 2, code review process, right? And say that freestyle and say okay to it. Now, when you create the second job, this is about reviewing the code, right? So source code management, we do it. Again, you must review the same source code. So I'll be giving the same project URL, right? I'll give this one, right? And then here under the build triggers, now when this job should be triggering it, automatically without my manual intervention. After, it is a sequential, right? Not a hook again, right? It is that a sequential process. Only the first job will be listening to the GitHub. Now, once the compilation is complete, then I have to trigger this. I do not want a parallel execution. I want a serial execution or a sequential process. The pipeline is always a sequential execution of various stages, various jobs that you do it. Now, first thing is that it is watching the GitHub, so you will trigger that. Now, whenever the compilation is completed, then you would come and then trigger this one. That is where I will use some other option here, build after other projects are built. So which means that will give you like, okay, which job you want me to watch it. I'll say that you watch over job 1. So whenever the job 1 is completed, whenever job 1 triggers and it has a successful execution, you will have to build it automatically. That's what I give it here. Now, once after this one is done, I will also go for build environment. There is nothing. I'll go to the build section here. Now I'll use the Maven again here, right? I'm asking Maven to do the code review, right? I'll use Maven and I use something called as PMD here. We call it nothing but -P. We see that matrix and use a PMD, which is a program mistake detector. We call it thing. PMD is a tool, or just like your Maven, or Maven uses this PMD extension to review the code. PMD is kind of set of standard rules that are defined it. Now your Maven compares your source code against this PMD rules, right? And will validate, okay, is this as per the standard or not? That is what all it is going to do it. We are asking Maven to take the source code, and there are predefined rules which are having a PMD, right? Which Maven can have it. So Maven looks at this PMD, which is program mistake detector, rules and regulations that are predefined rules. Take the source code, compare them, right? And it will give you necessary results once after you do it. Are the goals predefined? Yes, that's absolutely correct, Pandit. All the goals are predefined. You cannot write anything as your own. Everything is a predefined keys there. Okay, so those are the things that I can do it. Now, once you do this team, consider that, save it. Now I'm asking Maven to do it. Let it do it. Let's say that I'm building manually. We'll build it later, okay? So build now, you do it. Now, when you build this one, it is also going to do the standards again, it is going to generate some results. Now you can see that it is a build success again. This is another stage of build, but here team, it is going to generate some results again. The results are always available under the target folder. That definitely does some code review. Code review results need to be there. Is there any mistakes? Is there any warnings? Where are the results? Now the results will always be available under the workspace team. You must be aware of that. Say that here under that there is a target folder where we were seeing the compilation class files. Similarly, you will see here the compilation or the code review standard results. There is something called as pmd.xml, right? Now the pmd or Maven writes all the results into this XML file. Now, if you can understand the XML file here, read the XML file. Okay, there must be some warnings, some exceptions, something will be there like unused code, empty code, right? Unnecessary something. So empty code again, there would be some kind of issues that you normally see it, right? These results team which are in the XML format, which is not a good way for our understanding. Maybe developer would understand it. We are not really sure again, but we needed a better format of it, right? We will convert this into a better format later, but this is what it is. So if there is no build tool like Maven or Ant, then how to build the application? Okay, there is a possibility like Java provides, because the Java application, there is a command called as Java C, Java compiler we call it. So they're using a Java C, you can build it, but there is a lot of things need to be taken care manually if you don't have a build tool such as Maven. Good enough. So the Java let you build your application with its own native tools like Java C, that is there, but still it is better that you have a better automation tool like Maven or a build tool that will help me build the application easily than running the traditional Java commands. So is there no build tool like Maven and how to build? Okay, that's what I told you just now. You have one project like that. Is this a Java project you have it? Is that a Java project? So they might be using some kind of old methods like Java C is doing that one mostly. You must check that how they are building it. Mostly they will use Java C only. That's all the option you have it. The traditional way of Java building. Right, but there are a lot of dependencies need to be there. Each file need to be compiled, converted accordingly. There is a lot of manual work that need to be taken care. So try that one out accordingly. So here it is. Now you can see that we have a second job which is getting some results team, but I'm not able to understand it. But how would I understand these results in a better way is that by converting the results into a better format, right? So as we know that team, Jenkins is a very basic tool, but it will help me extend the functionality of the Jenkins. Now, do you know the meaning of a plugin by any chance, everybody? You guys know about the plugin? What is a plugin basically? You have it? Yes, team. What is a plugin? Anybody have an idea about plugin? It's a library. Okay. What does a plugin do? It's an API. Okay. What does a plugin do? What is the functionality of a plugin? Plugin means helping tool. Okay, great. So let me try that, right? Let me tell you in this way, like plugin is a piece of code again. It's a piece of software which will extend the basic functionality of a software, right? Consider that team, when you purchase a phone, the basic phone that you have it like an Android or Apple, you get a normal default applications in your phone. But do you stop using those applications, or do you have anything extra that gets installed? You normally go for App Store or a Play Store, and then you start adding more and more applications to your phone. So what exactly we are doing it? We are extending the functionality of our phone to utilize various resources or various services. Now that is the same concept applies for any other software also. Like Jenkins is also some kind of a software. It might not have a basic functionalities which I needed. So where Jenkins allows me to install something, add something to this existing Jenkins software as an external application or a piece of code, that would extend the functionality of your Jenkins again, right? Now those things are called as your plugins for Jenkins. So we will plug in or we will plug something to the Jenkins so that I can use that tool accordingly again. Now, considering that, if I want to add some plugins to my Jenkins, I again go to the Manage Jenkins. Now I go to something called as Manage Plugin section under the System Configuration, right? Click on the Manage Plugins here. Now under the Manage Plugins, you go to the Available. Now under this Available section, team, you can install any type of plugins. Means there are many things available. PMD is one of the plugin here. PMD we call it as Program Mistake Detector. We already used, Maven also uses, but Jenkins has this plugin to read that XML file and convert into a nice format again. Let's say that PMD plugin, I just select it and install without restart. It will install the necessary dependencies and everything, but it will install it to you on the fly. Now, likewise, team, we are also going to install the necessary plugins as we go on work on with Jenkins, but right now PMD is necessary. So I'm installing the PMD only for you. So here it is, it installed successfully. But if you would like to install something else again, go to Manage Plugins, go to Available again. Let's say that I'm installing one another plugin, which is a build pipeline, right? I'm seeing that a build pipeline plugin that is also available. So let's select this build pipeline plugin. I'll be talking about it. Consider that I'm installing without restart this one also. So where I will be using that plugin, I'll be showing you, but consider that this is what all you do it. Okay. Now consider this one, team, you have successfully installed, right, the necessary plugins. Likewise, you can install any plugin, team. Tomorrow, if you want to integrate Jenkins with Ansible, you can install an Ansible plugin. If you want to integrate Jenkins with Kubernetes, you can install a Kubernetes plugin. If you want to integrate Jenkins with Docker, you can install Docker plugin. So there are many plugins that are available for Jenkins. That makes Jenkins is a wide popular tool. Basically, Jenkins has over 1500 plugins. Means that Jenkins can interact with any other technology in the market. Whatever you think about it, everything is possible with Jenkins. So that is why Jenkins is a very widely used open source continuous integration tool, which has a very good community support as well, which will let you do implement a complete CI/CD pipeline with ease. That is the purpose of this one, team. You must understand it. So why did I install a PMD plugin? Let me show you that. I'll go to the code review job again. So I have to reconfigure this if I want to do something else with this. So it will take me to the same location again where I configured my details, build triggers and build environment and build. Now within this one, team, you know that this command or this Maven is generating the pmd.xml, which is a result of my code review, but I'm unable to read that result. So what I'm doing is that I'm going to convert that result into a more understandable format, or we'll publish that result basically. So I'll do something called as post build action. Once you build it, you get results. Using that results, you build some other thing that is called as your post build action accordingly. So here under the post build actions, I have it publish PMD analysis result. That is says that it is deprecated, but it's okay to use it. Let's say that publish PMD analysis results. Now it will just ask you that, okay, give me the pmd.xml, I'll convert it, right? It is giving you this one. Let's copy this and put it here. That's all you're gonna do it, right? Which means that, team, if I give star star, it will go to the target location directly. It will pick up this pmd.xml. It will convert this XML file into an understandable format that we'll be looking at right now. So save this one and run it one more time. So it will take the results this time and convert into an understandable format for us. So it ran successfully, team. Open this one. Now you see that, team, on the left hand side, there is something called as PMD warnings, right? Click on the PMD warnings here. Now under that, you will see that, okay, I'm seeing the PMD results straight away in my Jenkins console itself. Now it is showing you the warning trend. There is some warnings, it says. Click on the warnings. It will take you to that where exactly you have it a problem within your code. Consider that I'll go to this utilities where I have the problem. Now we say that, let's say that I use something here, property loader.java file. There is a Java file in which it is throwing some, there are 3 warnings or something. Let's click on this, right? Under that, it says that there is something called as empty code, unnecessary code, unused code. Try this one. Now let's click on the empty code here. So it is going to the file property loader Java, on which line it has the issue that is also given to you. Click on this one, it will take you to that particular code, right? It says that, okay, you defined finally, or you defined a try method or a catch, try catch, you're trying to do it, but you have left it empty. If you're not using that, why did you define it? Now defining these kind of errors, team, this is a silly mistake. You may say that it's not throwing you error, you can use it. Of course I can use it without an error, I can deploy it, right? Definitely. But this would unnecessarily cause some my memory leaks. Means that if you're running this production application in a server, that would unnecessarily occupy my resource more, right? Because the more program that you write it, the more thread that will spin it up, the more resource you needed, like RAM, CPUs needed. This would unnecessarily would cause maybe some other issues, which is not really needed. Then why would you keep it, right? Now this is what we'll ask the developer basically. So if you're not using it, don't use it, remove it, so that it will not have any effect on my systems, because the systems need to run the application properly. So we have to identify such silly mistakes which would definitely increase the performance of your application and the stability of your application in the production like environments. So the code review process will help you identify this kind of a mistakes and help you resolve the issues at the development stage itself, and then you are able to convert, or you're able to provide a quality software to the end user always. That is what is something, team, you must understand it. So that's how you need to understand. That is the purpose of your code review stage. Here we have it. You may have multiple other stages also to validate various other things, but we are not doing them. So let's say that this is what it is. So you've done the compilation, which was good. You did the code review, that is also fantastic, and that's good. Now finally I'll do another stage where I will be converting my source code into the package, right? So freestyle again, say okay to it. Now you have this one, a source code management. Select the project, right, and select it and give it here. Now it is simple one. This need to be triggered after my job 2 is complete. So I'll say that again, build after the projects are built. Now let's say that job 2, which is a code review. So job 1 will be triggered based on the push happens. Once that is done, will trigger the job 2. Job 2 should trigger the job 3 automatically. That's what we are configuring here. Now consider that build environment, nothing. Under the build, I have this one, and see that invoke top level Maven targets again. Use the Maven. Jenkins is using the Maven to packages. Finally, we see that package. This is again a predefined goal itself. So we have it package. Now, whenever you see this one, it will convert the source code into an executable format now, which is going to be a war file. That is what we're going to understand it, right? Now I'll do this one. I'll build now. Now, once you run this package, team, your source code is completely converted into an executable format, where you will be seeing an executable format of application that you can take it out and start deploying onto a server. Now you can see that it says that building a war file, web app assembled in so on so second. Now it is assembling your complete web application into a single bundle. Nothing but your war file here. You can see that the sample app.war file that I got generated. Now where this war file is available again, under your target folder, as simple as that. So I can show you the workspace, right? Go to the workspace here. Now you go to the target folder. Under the target folder, you will see the war file, which means that the war file can be downloaded, or war file can be deployed onto various environments. Let's say that cd var lib jenkins workspace, I have it, right? Under the workspace, I have the job 3, right? Under this one, you will see the target folder. Under the target, you will normally see your war file that got generated successfully, which means that we have this war file. Now this war file is nothing but your application. This need to be deployed onto a server, such as a web server, and the web server will run this particular application for you, right? And it will let you access the application from the external sources accordingly, right? So this is just an understanding team, like this is what is called as your continuous integration, which we do it normally. But here you need to understand that, did we build the pipeline? Yes, we built it, but there is no clear view team here. Means right now we have only 3 jobs here. You're able to understand the sequence, but let's say that I built 100 or 200 jobs. There are 20 to 30 pipelines running on my Jenkins. Then how would I identify these dependencies? Which job should run after which job? This which job would run after which job, right? That is where team, the other plugin which I installed it will help me identify my dependencies with each job. So what I'll do is that here, very simple thing, go to the all here. Beside to all, there is a plus symbol that you see it. Create a visualization, right? That will help you to this one. Click on this one. Let's say that I'll call this as my CI pipeline, right? So I'll call it as build pipeline view. I'm generating a separate view for my application process or continuous integration pipeline. Select the build pipeline view and say OK to it. When you say OK team, it will take you to the next page. It will give the description, everything. That's okay. Now it is asking you to give the pipeline flow. So pipeline flow is nothing but the dependencies that you want to understand. So we say that upstream and downstream. What do you mean by upstream and downstream is that, consider that my job 1 has a downstream which is job 2. For a job 2, it is upstream is job 1 and the job 3 is a downstream. So you have one thing, dependencies, right? Upstream is a previous dependency, downstream is a what is after that, that is a dependency again. Those are things called as upstream and downstream config. In this, it is asking you to select an initial job. What is your starting thing? That is what asking you, just select it. And here you will see that, okay, say okay to it. Now it will generate a nice visualization for you, a pipeline that we call it normally. Now this pipeline would trigger automatically, or it will execute the things in a sequential order. Now the sequential execution of various stages in a build process is called as your a pipeline. Basically, we execute the pipeline. So let me make a change here in my source code. I'll do a commit again by adding some code here. Consider that I'm just publishing this one. Okay, commit the changes. Whenever I commit here, this entire flow will be triggered automatically. Just refresh it. Now you can see that it triggered automatically right now. The job 1 got triggered. Now once the job 1 is completed, the job 2 will be triggered automatically, right? I will not do anything, but you see that job 2 is got triggered, which means that we are having a working pipeline now, the continuous integration pipeline, that would give me an artifact or an executable file that can be taken and deployed onto various environments as per the interest according. So this is what it is, team. The blue color means that yet to run, the green color is a successful, and red color is a failure, and yellow color is a running job that you can see it. Now team, we are able to build our continuous integration pipeline with Jenkins, we call it. This is just a quick thing, team. On the top level we went through, but I'll stop here for a minute. If you have any questions, let me know, we can discuss that. Everybody have any question here regards to anything? Are we clear on what is the goal of a continuous integration pipeline and how does a continuous integration pipeline gets created? Anybody have any question on anything that we discussed so far? Okay, it says to have this one. We have to practice on Jenkins to ask question. Okay, great, Pandit. Definitely right. Yes, you have time till tomorrow. So please practice it. The videos will be available for you. Please practice it, and everything is available under the GitHub repository again, including the installation instruction, the configurations which I told you, right? All the configuration part, right? The plugins that you need to install it. So everything is written, documented, right? So you can go through this document and then let me know if you see any issues. We will work it tomorrow accordingly. Okay. So this is all for today, team. I hope you all enjoyed again. So let's meet tomorrow with more content on various tools and technologies that we'll be discussing. Okay. So until then, have a good night and take care. I'll see you tomorrow with more content. Where can I find the session video? It will be under your LMS, Rajan. Have you gotten access to your LMS? Did the people send you the LMS access, LMS links and everything or not? If not, I'll inform the team so they will send you the email regarding the LMS. Under that, you will be finding all the recordings, including the content that we are covering, everything. There's a GitHub repository links, everything will. Okay, so, okay, Atul, great. Thank you so much. So it is under your DevOpsUniversity.org itself, Rajan. That's you just need the credentials only. I think if you have not received the credentials, maybe you check your spam. Did you check your junk mail? Right? Did you check your junk or not? Check the spam also. Sometimes it will go to the spam. So if you do not see there, anyway, I'll inform the team to resend the emails. Right, Rajan, for you. So please go through that. You would have received already for sure, but ensure you check the junk and everything. If not, anyway, I'll inform the team now. So they'll be sending you that. You will be able to see it. Okay. Okay. So great team. So I'll see you tomorrow. Have a great evening. Take care. Thank you so much. Take care.